There is a place on Earth where you can stand lower than almost anywhere else on the planet's land surface, where the air feels thicker somehow, pressed down by the weight of atmosphere accumulating in this Great Depression, where the sun beats with particular intensity through fewer layers of sky. This is the shore of the Dead Sea, 430 meters below the level of the distant oceans, the lowest point of dry land on Earth, a geographical superlative that seems fitting for a body of water defined by extremes. The approach reveals itself slowly if you come from Jerusalem, descending through the Judean desert on roads that wind down escarpments of limestone and chalk, passing through landscapes that grow progressively more barren, more severe, more alien as you drop below sea level into what feels like another world entirely. The vegetation thins and disappears. The soil gives way to bare rock, then to slopes of loose scree in shades of cream and gold and rust. The temperature rises with each switchback, each 100 meters of descent adding degrees to the thermometer, until the heat becomes almost physical, a presence you move through rather than merely experience. And then you see it, spread before you in the haze of distance, a body of water that gleams with an unnatural intensity, its surface reflecting light in ways that seem wrong somehow, too bright, too sharp, as though the water itself were made of something other than water. The color shifts with the hour and the season, sometimes deepest blue, sometimes turquoise, sometimes a milky gray-green that speaks of minerals in suspension, of chemistry rather than biology. There are no boats upon this sea, no birds wheeling above it, no reeds or grasses softening its margins. The shore is harsh and white with salt, crystalline formations growing where waves lap against land, creating borders of mineral that crunch beneath your feet like snow that will never melt. This is the Dead Sea, and it has been here in one form or another for millions of years, filling the deepest part of the Jordan Rift Valley, that great tear in the Earth's crust that runs from Syria through the Red Sea and into Africa. It is the remnant of ancient seas that once covered this region, concentrated and intensified by ages of evaporation under the relentless Middle Eastern sun, growing saltier and heavier and stranger with each passing millennium. It has witnessed the rise and fall of civilizations, has been mentioned in some of humanity's oldest texts, has provided resources that ancient peoples valued and modern industries exploit. It is, simultaneously, one of Earth's natural wonders and one of its most endangered ecosystems, a place where geological time and human history intersect in ways both profound and troubling. The water itself is extraordinary, unlike any other water on Earth in its composition and its properties. When you wade into the Dead Sea for the first time, the strangeness begins immediately. The water feels slick, almost oily against your skin, a sensation caused by the magnesium salts that make up a significant portion of its mineral content. It is warm, especially in summer, heated by the sun and retaining that warmth in its dense, heavy mass. And then, as you venture deeper, comes the experience that has drawn curious visitors for thousands of years, the impossibility of sinking, the strange buoyancy that lifts you effortlessly to the surface, that allows you to float without effort, to recline in the water as though held by invisible hands. This buoyancy is a consequence of density. The Dead Sea contains roughly 34% dissolved salts, nearly 10 times the salinity of the ocean. This makes the water significantly denser than your body, denser even than seawater, dense enough that it cannot help but support your weight with ease. The sensation is disorienting at first, a fundamental violation of how water is supposed to behave, how your body is supposed to respond to immersion. You cannot sink even if you try. Your legs float up of their own accord. Swimming in the conventional sense becomes impossible. The water is too thick, too heavy, too resistant to the normal motions of propulsion. Instead, you float, passive and supported, cradled by water that is more mineral solution than water in any normal sense of the word. The history of human interaction with this strange sea stretches back into the depths of time, back beyond written records into the realm of archaeological inference and mythological memory. The ancient peoples who lived around its shores knew it by many names. The Hebrews called it Yam HaMalach, the Salt Sea, a straightforward description of its most obvious characteristic. The Greeks and Romans knew it as Lake Asphaltites, after the bitumen that floated to its surface and could be harvested for use in everything from medicine to mummification. In Arabic, it is Bar Lut, the Sea of Lot, connecting it to that biblical figure whose wife, according to tradition, was transformed into a pillar of salt as she looked back at the destruction of Sodom and Gomorrah. That story, that ancient narrative of divine judgment and human weakness, of cities consumed by fire and brimstone, and a woman frozen forever in a moment of disobedience, is woven into the very landscape here. Somewhere along these shores, tradition holds, stood those infamous cities, wealthy and wicked, destroyed so utterly that their exact locations remain uncertain, subjects of archaeological speculation and theological interpretation. The salt pillars that dot the southern shores and rise from the water itself become, in this mythological framework, monuments to that ancient destruction, physical manifestations of a story that has resonated across millennia, that has been told and retold in countless languages, that has shaped how billions of people understand the relationship between human behavior and divine response.
But the salt pillars are also geological facts, formations created by natural processes that have nothing to do with ancient cities or moral lessons. They are the products of salt tectonics, of the immense deposits of halite that underlie this region, pushed upward by geological forces, exposed to rain and wind and the fluctuating water level of the sea itself. Some are small, mere crystalline projections from the shore. Others are substantial, pillar-like formations that rise meters into the air, white and gleaming, sculpted by erosion into forms that the imagination can easily read as human, as the frozen figure of a woman looking backward, forever trapped between two worlds, unable to escape the past that drew her gaze, even as the future burned behind her. The most famous of these formations, the one identified by tradition as Lot's wife herself, stands on Mount Sodom, the salt mountain that rises at the sea's southwestern edge. It is a towering pillar of nearly pure sodium chloride, weathered and reformed countless times over the centuries, yet persistent, present, a landmark that has drawn pilgrims and curious travelers for generations. Whether you accept the religious significance or see it merely as a curious geological formation, there is something compelling about standing before this pillar, this column of salt rising from a mountain of salt beside a sea of salt, contemplating the layers of meaning, geological, historical, mythological, spiritual, that accumulate around such landmarks. The salt itself tells stories if you know how to read them. In the Dead Sea's salt, in the layers of sediment that accumulate on its bed, in the cores that scientists extract and analyze, there is recorded a history of climate and environment stretching back hundreds of thousands of years. Periods of greater rainfall show up as layers of less concentrated salt, times when the sea was larger, deeper, less saline. Periods of drought appear as highly concentrated salt deposits, times when the sea shrank, when evaporation outpaced the flow of water into this terminal basin. Reading these layers is like reading tree rings, each one a marker of a year, a decade, a century, a record written in minerals of the changing conditions of this region. And then there is the asphalt, that strange black substance that appears on the sea's surface, that floats despite its seeming heaviness, that ancient peoples harvested and valued for its many uses. Natural asphalt, or bitumen, seeps from deposits deep beneath the Dead Sea's bed, rising through cracks and fissures, emerging into the water where it congeals into chunks and masses that float to the surface. In ancient times, this was a valuable commodity, used as a waterproofing material, as an adhesive, as a component in medicines and cosmetics, even in the process of mummification. The Egyptians, in particular, valued Dead Sea asphalt, importing it for use in their elaborate funeral practices, applying it to preserve the bodies of their dead for their journey into eternity. The sight of black asphalt floating on the bright surface of the Dead Sea must have seemed miraculous to ancient observers, must have reinforced the sense that this was a place of wonders and mysteries, where the normal rules did not apply, where the earth itself produced treasures from hidden depths. The harvesting of this asphalt was sometimes dangerous work. It required venturing onto the water in boats or rafts, approaching the floating masses, securing them and towing them to shore. In a body of water where no fish swam, where nothing grew, where the very water could burn your eyes and damage your skin if you were not careful, this work carried risks. Yet people did it, generation after generation, because the asphalt was valuable, because it had uses that justified the danger and the difficulty. Today, the natural seepage of asphalt continues, though it is less common than in ancient times, less pronounced. Modern observers occasionally report seeing patches of dark material on the water, remnants of that ancient phenomenon. But the asphalt, like so much else about the Dead Sea, has been overtaken by modern industrial operations, by the large-scale harvesting of other minerals, by the transformation of this ancient sea into a source of potash and magnesium and bromides, chemical elements extracted in enormous quantities for use in fertilizers, in industrial processes, in the countless applications of modern chemistry. The Jordan River, that biblical waterway whose name resonates through religious texts and historical accounts, flows into the Dead Sea from the north, bringing with it the drainage of the Sea of Galilee and the waters of the Yarmouk River and countless smaller streams. Or rather, it once did. The Jordan's flow into the Dead Sea has been reduced to a trickle, diverted for agriculture and drinking water, for the needs of modern populations in Jordan and Israel, for the irrigation that makes the desert bloom and sustain millions of people. This diversion, this interruption of the natural hydrological cycle, is slowly killing the Dead Sea, causing its level to drop by more than a meter per year, exposing shores that were underwater within living memory, creating environmental catastrophes in the form of sinkholes that suddenly open in the earth, swallowing roads and buildings, making large areas along the shore dangerous and uninhabitable.
But we are getting ahead of ourselves, moving too quickly through the long story of this remarkable place, rushing toward the present when we should linger in the past, should wade slowly through the centuries and millennia that have seen human civilizations rise and fall along these heavy waters. Let us step back. Let us move more slowly through the history and the geology, through the chemistry and the mythology, through all the layers of meaning that make the Dead Sea something more than merely a salt lake in a desert rift valley. Let us explore the salt pillars and the asphalt, the ancient harvests and the modern industries, the biblical accounts and the geological realities, the human dramas and the patient processes of deep time. Let us descend, as visitors have descended for thousands of years, to the lowest point on earth, to see what secrets and stories accumulate in this place of extremes. The water of the Dead Sea is heavy. This is not a metaphor, not a poetic description, but a simple physical fact. When you lift a container of this water, when you pour it from one vessel to another, you feel its density, its mass greater than an equivalent volume of fresh water would be. The specific gravity of Dead Sea water is approximately 1.24, meaning it is 24% denser than pure water. This density is the direct result of its extraordinary salt content, the minerals dissolved in such concentration that the water itself becomes something else, something between liquid and solution, between water and brine. The composition of this mineral cocktail is complex and varies somewhat between the northern and southern basins of the sea, but certain components dominate. Magnesium chloride is the most abundant dissolved salt, making up more than 50% of the total dissolved solids. Sodium chloride, common table salt, accounts for about 30%. Calcium chloride, potassium chloride, and various other salts and minerals make up the remainder. The result is a liquid whose chemistry is radically different from seawater, despite both being salty. Where seawater is dominated by sodium chloride with smaller amounts of other salts, dead seawater is dominated by magnesium salts, creating different properties, different behaviors, different interactions with materials and organisms. This chemical composition has profound effects on anything that enters the water. Human skin feels the difference immediately. The magnesium-rich brine is hygroscopic, meaning it attracts and absorbs water, drawing moisture from your skin, creating that peculiar slick feeling that coats your body. The sensation is unlike bathing in any other natural water, unlike even swimming in very salty ocean water. There is a thickness to it, a resistance, as though the water itself has more substance than water should have. Some find this pleasant, soothing even, claiming therapeutic benefits from the minerals. Others find it unsettling, too alien, too far from what water is supposed to feel like. The buoyancy is the most famous property, the characteristic that has made the Dead Sea a tourist attraction and a subject of wonder since ancient times. Historical accounts from classical authors describe the impossibility of sinking in these waters, the way condemned criminals thrown into the sea would bob to the surface, unable to drown, kept alive by the very waters meant to execute them. Whether these accounts are accurate history or embellished anecdote is uncertain, but they speak to the long-standing awareness of this water's unusual properties, the way it defies normal expectations and behaviors. The experience of floating in the Dead Sea has become almost iconic, photographed countless times, appearing in travel documentaries and personal vacation albums, always showing the same pose, a person reclining in the water, apparently effortless, often reading a newspaper to emphasize the ease of flotation, the impossibility of sinking. This image has circulated widely enough to become a cliché, yet the actual experience remains genuinely strange and disorienting, especially for first floaters. Your body does not behave as you expect it to. You cannot adopt normal swimming positions. Your legs insist on floating upward. Your torso tilts back. You find yourself constantly adjusting, trying to find a stable position in water that seems determined to keep you on its surface rather than allowing you to move through it. But while the buoyancy might be pleasant, even amusing, the water itself is harsh, potentially dangerous if not treated with respect. Getting Dead Sea water in your eyes causes immediate, intense pain, a burning sensation far worse than seawater would cause, requiring immediate flushing with fresh water to relieve. Swallowing the water can cause nausea and vomiting, and drinking any significant amount could be fatal, the high mineral content potentially causing dehydration and electrolyte imbalances that the body cannot easily correct. Even prolonged immersion can be problematic. The minerals leach moisture from the skin, and the combination of high salt content and intense sun can lead to severe irritation or burns. The water's density affects more than just buoyancy and human comfort. It affects how the sea itself behaves, how it stratifies and mixes, how heat transfers through it, how waves form and move across its surface. The Dead Sea is notable for the relative calm of its waters, the absence of the kind of wave action you see in oceans or even in normal lakes of comparable size. The heavy water resists being pushed by wind, resists forming the rolling swells and breaking waves that characterize bodies of water with normal density. Instead, the surface is often relatively smooth, disturbed only by gentle ripples, creating that mirror-like quality that makes the sea's reflection of the surrounding mountains and sky so sharp, so clear, so intensely beautiful in certain lights.
The thermal properties of this dense brine also differ from normal water. It holds heat more efficiently, warming under the desert sun and retaining that warmth well into the evening and night. In summer, the surface temperature can reach 35 degrees Celsius or even higher, creating conditions that are bath-like, almost uncomfortably warm. This warmth, combined with the mineral content, has led to the Dead Sea's reputation as a therapeutic destination, a place where the combination of minerals, warmth, and the unique atmospheric conditions at this low elevation create conditions believed to benefit various skin conditions, arthritis, respiratory problems, and other ailments. The ancient world certainly recognized these therapeutic properties. Roman and Byzantine sources describe health resorts along the Dead Sea shores, places where wealthy individuals would come to bathe in the mineral-rich waters, to coat themselves in the mineral-rich mud found along the shores, to breathe the dense, oxygen-rich air of this below-sea-level location. Herod the Great, the builder of Masada and the Second Temple, was said to have bathed in the Dead Sea waters seeking relief from his various ailments. Cleopatra, according to some accounts, valued Dead Sea products highly, even allegedly conquering portions of the region to secure access to the balsam groves and mineral resources around the sea. This medicinal reputation has continued into modern times, creating a wellness industry around the Dead Sea that draws visitors from around the world. Hotels and spas line portions of both the Israeli and Jordanian shores, offering treatments using Dead Sea mud and minerals, providing access to the water itself, promising healing and rejuvenation through exposure to this unique environment. The scientific evidence for many of these claims is mixed. Some conditions do seem to respond positively to Dead Sea therapy, while for others the benefits are less clear. But the belief persists, as it has for millennia, that there is something special about this water, something that goes beyond mere chemical composition, something that makes it not just different, but potentially transformative. The weight of the water manifests in other ways as well, in how it interacts with the environment, how it shapes and is shaped by the landscape around it. When the water level drops, as it has been doing for decades, it leaves behind terraces of salt, layered deposits that mark previous shorelines, creating a staircase of mineral that descends from what was once underwater to what is now exposed to air. These salt formations are fragile yet persistent, dissolving in rain but reforming as the sun evaporates moisture, creating temporary sculptures that change with each weather pattern, each season, each fluctuation in humidity and temperature. The mud of the Dead Sea shore is equally distinctive, a thick black ooze, rich in minerals, formed from the sediments that wash down from the surrounding mountains, mixed with the salts and minerals of the sea itself. This mud has been harvested and packaged and sold for cosmetic use, exported around the world as Dead Sea mud, marketed for its supposed skin benefits, its mineral content, its exotic origin. Whether it has any real therapeutic value beyond what any good quality clay might provide is debatable, but its cultural cachet, its association with this famous location, gives it value in the marketplace of wellness and beauty products. The weight of the water is also historical, metaphorical, the accumulated gravity of millennia of human association with this place. The Dead Sea has been known to humanity for as long as there have been humans in this region, which is to say for tens of thousands of years. Archaeological sites around its shores reveal successive waves of occupation, of people drawn to this harsh yet resource-rich environment, people who learned to exploit its offerings while coping with its challenges. The combination of fresh water springs along the western shore, the salt and other minerals the sea provided, the strategic position within the Jordan Valley system, all made this an important region despite the inhospitable conditions. The weight's heaviness is chemical, physical, historical, mythological. It is the literal weight of dissolved minerals, 34 grams in every 100 grams of water. It is the metaphorical weight of the past, of the stories and struggles that have unfolded along these shores, of the civilizations that have risen and fallen within sight of these heavy waters. It is the weight of expectation, of the reputation that precedes every visitor's first encounter with this famous sea. And it is the weight of mortality, the knowledge that this sea, for all its ancient persistence, is dying in our time, shrinking at a rate that makes its long-term survival uncertain, adding urgency and melancholy to every visit, every study, every contemplation of its strange and heavy waters. The Dead Sea sits within one of Earth's most dramatic geological features, though you might not realize it from ground level, might not grasp the full scale and significance of the rift valley that contains it unless you see it from above or study maps that reveal the larger context. This is part of the Great Rift Valley system, that immense fracture in Earth's crust that extends from Syria in the north through the Jordan Valley, down through the Dead Sea in the Arava Valley to the Gulf of Aqaba, then continues south as the Red Sea, and ultimately splits into the East African Rift, extending all the way to Mozambique. It is one of Earth's most significant geological features, a place where tectonic plates are pulling apart, where the African plate and the Arabian plate are slowly separating, moving at rates measured in millimeters per year, but accumulating over millions of years into movements measured in hundreds of kilometers.
The formation of the Dead Sea Basin is tied to this tectonic activity, to the creation of the Rift Valley itself. As the plates pulled apart, the land between them subsided, dropping below sea level, creating a depression that filled with water from the Jordan River and other sources, forming a series of lakes that have expanded and contracted over geological time in response to climate variations. During wetter periods, during ice ages when global climate patterns brought more precipitation to this region, the Dead Sea was much larger, deeper, covering areas that are now dry land, extending far beyond its current boundaries. During drier periods, it shrank, concentrated, became even saltier than it is today, perhaps even drying up entirely in some extreme climatic events. The evidence for these fluctuations is written in the landscape if you know how to read it. Ancient shorelines are visible as terraces on the surrounding hillsides, marks left by water that once stood hundreds of meters higher than today's sea level. These terraces can be dated, their ages determined through various geological techniques, allowing reconstruction of the sea's history over hundreds of thousands of years. What emerges from this analysis is a picture of a body of water that has constantly changed, never static, always responding to the balance between water flowing in and water evaporating away, between the input from the Jordan and the relentless thirst of the desert sun. The depth of the Rift Valley itself is extraordinary. The floor of the Dead Sea, at its deepest point in the northern basin, lies more than 700 meters below sea level, not the water surface, but the actual bottom of the sea bed. This makes it one of the deepest points of dry land on Earth, though dry is perhaps not the right word for the bottom of a body of water. The total thickness of water and sediment in the basin is even greater. Sediment cores have penetrated more than 4 kilometers of deposits, revealing layer upon layer of accumulated salts, muds, and other materials laid down over millions of years of the basin's existence. The surrounding landscape reflects the geological forces that created this depression. To the west rise the Judean hills, limestone plateaus cut by deep wadis, desert canyons that channel the occasional flash floods down toward the sea. These hills are themselves raised up by the same tectonic forces that depressed the Rift Valley, creating the dramatic elevation change, a rise of more than 1,000 meters in just a few kilometers of horizontal distance. The effect is of standing at the bottom of a vast natural amphitheater, surrounded on all sides by mountains and plateaus that seem to lean inward, focusing attention on the sea itself. To the east, across the water, rise the mountains of Jordan, equally dramatic, equally barren, creating a symmetrical frame for the sea itself. Between these eastern and western highlands lies the floor of the Rift Valley, flat and harsh, covered in salt flats and mud flats, and the degraded remains of what was once underwater. The heat here is intense, concentrated by the depression's depth, by the reflection of sun from white salt and pale rock. In summer, temperatures regularly exceed 40 degrees Celsius, making this one of the hottest places on Earth, a competition with Death Valley and the Danakil Depression for the title of world's hottest low-elevation location.
The geology of the region is complex, a mixture of sedimentary rocks laid down in ancient seas, metamorphic rocks altered by heat and pressure, and more recent deposits of salt and gypsum precipitated from the evaporating waters of the Dead Sea itself. Mount Sodom, that salt mountain at the southern end of the sea, is particularly fascinating geologically. An entire mountain made primarily of halite, salt in nearly pure form, mixed with other evaporite minerals. It is a diapir, a rising dome of salt pushed upward from deeper deposits by geological pressure, exposed at the surface where it forms a landscape unlike almost anywhere else on Earth. Walking on Mount Sodom is a strange experience. The rock underfoot is literally salt, the same substance you might sprinkle on your food, here forming solid ground, cliffs, and valleys. Rain dissolves the surface, creating bizarre formations, caves and channels carved not by mechanical erosion, but by solution, by water literally dissolving the rock and carrying it away. The mountain is constantly changing, losing mass to every rainstorm, yet it persists, pushed upward from below by the same forces that created the Rift Valley, by the thickness of salt deposits that accumulated over millions of years of evaporation. These salt deposits tell a story of extreme conditions persisting over vast time spans. For salt to accumulate in such thickness requires sustained evaporation in a closed basin, requires conditions where water flows in but can escape only by evaporating, leaving its dissolved minerals behind. The Dead Sea has been this kind of terminal basin for millions of years, though its size and salinity have varied enormously. The salt beneath Mount Sodom and beneath the sea itself represents the accumulated residue of countless years of this process, of water arriving, evaporating, leaving salt, repeating in endless cycles until the deposits reach depths measured in kilometers. The Rift Valley itself is still active, still moving, still experiencing the tectonic forces that created it. Earthquakes are common in this region, not usually major ones, but frequent enough to remind inhabitants that they live on the boundary between crustal plates, on ground that shifts and settles. Historical accounts record destructive earthquakes in this region, events that damaged cities, changed landscapes, possibly even affected the level and extent of the Dead Sea itself. The biblical destruction of Sodom and Gomorrah is sometimes interpreted as possibly recording an earthquake or related geological event, though this remains speculative, mixing myth with geology in ways that are difficult to untangle.
The landscape around the Dead Sea has a stark beauty, a minimalist aesthetic of earth tones and harsh light. The mountains are bare of vegetation except at the highest elevations or near springs. The wadis that cut through them are equally bare, dramatic gorges of sculpted rock with no softening presence of plant life. The colors are subtle but varied, the creamy whites and yellows of limestone, the darker browns of chert and flint layers, the reddish tones of iron-rich sediments, the pure white of salt deposits. Under the intense sun of midday, these colors wash out, become almost monochromatic, but at sunrise and sunset they glow, warm tones intensified by the low angle of light, creating landscapes that seem almost painted, too vivid to be real. This geography of extremes, this landscape of the lowest and the harshest, has shaped everything that happens here. It has determined what plants and animals can survive, what humans can accomplish, what history unfolds. The very extremity of the place creates its character, makes it not just different, but unique, one of Earth's singular environments where conditions combine in ways found nowhere else. To understand the Dead Sea, you must understand this geography, must feel the pressure of depth, the concentration of heat, the enclosing presence of mountains that trap this depression and everything within it, creating a world apart, a place of extremes where the normal rules seem suspended, where water is too heavy to drown in, where mountains are made of salt, where the very ground beneath your feet sits lower than the surface of the distant oceans.
The wadis that descend to the Dead Sea are themselves dramatic features, canyons carved by water in a place that receives almost no rain. This is the paradox of desert landscapes. They are shaped by water, sculpted by flash floods and seasonal flows, yet water is their scarcest resource. When rain does fall in the highlands above the Dead Sea, it comes in intense bursts, storms that drop their moisture quickly, creating torrents that race down the dry wadis, carrying everything before them: rocks, boulders, soil, whatever lies in their path. These flash floods are dangerous, capable of sweeping away vehicles and people, transforming dry canyons into raging rivers within minutes. But these floods are also life-giving, depositing soil and nutrients, creating temporary watercourses that allow vegetation to briefly flourish, filling pools that persist for days or weeks after the flood has passed. In some of the larger wadis, particularly those like Wadi Kelt or Ain Gedi, where springs provide permanent water, these flood deposits have created ecosystems that stand in sharp contrast to the surrounding desert. Trees grow here, palms and acacias, tamarisks and willows. Birds nest in their branches. Ibex come down from the mountains to drink. For a few hundred meters on either side of the water, life clusters, intense and concentrated, before giving way again to the barren slopes and ridges that characterize most of this landscape. The geology continues to reveal itself in the rocks, in the layers that tell stories of this region's deep past. The limestone plateaus were formed from sediments deposited in ancient seas millions of years ago when this region was underwater, when marine organisms lived and died and accumulated their calcium carbonate shells on the seafloor, eventually compressing into rock. Later geological forces lifted these seafloors into mountains, exposing them to erosion, creating the dramatic topography we see today. Within the limestone, you can sometimes still find fossils, the preserved remains of ancient marine life, shells and corals, and other organisms that lived in warm, shallow seas that have long since vanished. These fossils remind us that the Dead Sea, for all its ancient persistence, is relatively young in geological terms. The current phase of the Dead Sea, the specific body of water that exists today, is perhaps 15,000 years old, dating to the end of the last ice age. But the Rift Valley itself is millions of years old, and bodies of water have occupied this depression for much of that time, though they have varied enormously in size and character. The geological record preserves evidence of these earlier lakes, their sediments mixed with those of the current sea, creating a complex stratigraphy that scientists continue to study and interpret. The relationship between the Dead Sea and the broader Rift Valley system is intimate and ongoing. The sea is not separate from the valley, but rather an expression of it, a consequence of the same tectonic processes. As the rift continues to widen, as the Arabian and African plates continue their slow divergence, the Dead Sea Basin will persist, will continue to be the low point into which water drains, will continue to be the place where that water evaporates, leaving behind the minerals that make it so distinctive. In this sense, the sea is both temporary and permanent, temporary in its specific form and characteristics, permanent in its position and essential nature as the collecting point for water in this Great Depression.
The geology also explains some of the sea's other distinctive features. The presence of asphalt, that black bitumen that seeps from the sea floor, is a consequence of the organic-rich sediments that have accumulated in the basin, sediments that under heat and pressure have transformed into petroleum products. The Rift Valley's geological activity provides the heat and pressure necessary for this transformation, and the fractures and faults that characterize the valley floor provide pathways for the resulting asphalt to migrate upward, to seep through the seabed and float to the surface. This same process occurs in other rift valleys and sedimentary basins around the world, but few places make it so visible, so accessible as the Dead Sea does. The salts themselves are not uniform, but vary in composition from place to place and depth to depth, reflecting different sources and different periods of formation.
Some salts come from the dissolution of ancient evaporite deposits, salt beds that formed millions of years ago and are now being redissolved by groundwater and brought to the sea. Others come from the weathering of rocks in the watershed, minerals leached out by water and carried in solution to the sea. Still others are produced by the evaporation of the seawater itself, precipitating out in layers on the sea floor as concentrations exceed saturation levels. The result is a complex mixture, a mineral cocktail that varies seasonally and spatially, that creates different conditions in different parts of the sea. This geological complexity, this layering of processes and timescales and materials, is part of what makes the Dead Sea so scientifically valuable. It is not just a curiosity, not just an extreme environment, but a natural laboratory where processes that occur elsewhere in less obvious forms are concentrated and visible. Studying the Dead Sea provides insights into evaporite formation, into the chemistry of hypersaline lakes, into how life adapts or fails to adapt to extreme conditions, into how climate change affects closed basins, into countless questions that have applications far beyond this specific location. The geography of extremes that defines this place is not static but dynamic, constantly responding to the interplay of geology, climate, and increasingly human activity. The sea's level has fluctuated by hundreds of meters over millennia, responding to climate variations, to wet periods and dry periods, to ice ages and interglacials. But the current drop in level is happening faster than any natural fluctuation in recent geological time, driven not by climate, but by human diversion of water, by the interruption of the Jordan's flow, by the extraction of minerals from the sea itself. The geography is changing before our eyes, new features appearing as old shorelines are exposed, sinkholes opening where underground salt layers dissolve as the water table drops, creating a landscape in rapid transformation. This transformation adds a layer of urgency to the contemplation of this place, a sense that what we see today may not persist much longer, that the Dead Sea as it has existed for millennia is under threat in our time. The geography of extremes is becoming more extreme, the lowest point dropping lower, the harsh conditions growing harsher, the delicate balance that has maintained this sea for thousands of years tipping toward imbalance, toward a future where the Dead Sea might become not just smaller, but fundamentally different, perhaps even cease to exist as a single body of water, splitting into smaller pools, eventually perhaps disappearing entirely, leaving only salt flats and the memory of water where water once lay. The salt pillars rise from the southern shores and the shallow waters of the Dead Sea like monuments to some alien geometry, like the ruins of a civilization that built in crystals rather than stone. They are white, gleaming white, a whiteness that seems to absorb and reflect sunlight simultaneously, creating surfaces that hurt to look at directly in the midday sun. Some are small, no larger than a person. Others tower meters into the air, substantial structures that have persisted for years or decades despite the forces of dissolution that constantly work against them. They are not permanent in any absolute sense. No salt formation exposed to weather can be truly permanent, but they persist, they endure, they recreate themselves through the same processes that destroy them. The formation of these salt pillars is a consequence of the Dead Sea's extraordinary salinity and the processes of evaporation and precipitation that dominate this environment. As water from the sea laps against the shore or seeps through underground passages, it evaporates, leaving behind the minerals it carried in solution. Salt crystallizes from this concentrated brine, growing grain by grain, crystal by crystal, building up layers that eventually form substantial structures. The process is similar to the formation of stalactites and stalagmites in limestone caves, but here the material is halite rather than calcite, salt rather than calcium carbonate, and the process happens in air and light rather than in the darkness underground. The pillars grow in various forms depending on local conditions. Some are solid columns, others hollow or partially hollow, their interiors creating caves and chambers where water has dissolved salt even as it precipitates on the exterior. Some are smooth, their surfaces showing the regular geometry of salt crystals. Others are rough, encrusted with additional minerals, coated with the wind-blown dust that sticks to their wet surfaces. Some stand alone, isolated formations rising from otherwise flat terrain. Others cluster together, creating forests of salt, groves of mineral where you can walk between the pillars, can reach out and touch their crusty surfaces, can break off pieces that crumble in your hand into granules of pure salt. The most famous of these formations, the one that has captured human imagination for millennia, is the pillar identified as Lot's wife, that geological feature that has become inseparable from the biblical narrative of Sodom and Gomorrah. The story is well known, recorded in Genesis, elaborated in later Jewish, Christian, and Islamic traditions. Lot and his family fleeing the destruction of the wicked cities, warned not to look back, Lot's wife disobeying, turning to see the catastrophe, and for her disobedience being transformed into a pillar of salt, frozen forever in that moment of backward glancing, of longing for what was being destroyed, of inability to move forward without looking back. The geological formation that bears her name stands on Mount Sodom, that salt mountain that rises at the sea's southwestern edge. It is a pillar of nearly pure salt, between 10 and 15 meters tall, depending on how you measure it and how much has eroded since the last measurement. Its form is suggestively anthropomorphic, especially when viewed from certain angles, seeming to show a human figure, head bowed, perhaps looking backward over a shoulder, captured in mineral immobility. This resemblance is probably accidental, the result of erosion patterns that happen to create a form our pattern-seeking minds read as human. But the resemblance is compelling enough that the identification has persisted for centuries, perhaps for millennia, with pilgrims and travelers coming to view this formation as a confirmation of the biblical story, as physical evidence that the narrative of Lot and his wife is not merely myth, but history. The reality is more complex and more interesting than simple confirmation or refutation of ancient stories. The salt pillar is real, is there, is genuinely remarkable. The biblical story is ancient, is powerful, has shaped the religious and cultural consciousness of billions of people across millennia. The two, the geological formation and the narrative, have become intertwined, each giving meaning to the other, the physical reality lending credibility to the story giving significance to what might otherwise be merely an interesting mineral formation. This intertwining of natural feature and human narrative is characteristic of sacred landscapes everywhere, places where the physical world and the world of meaning merge, where geology and theology occupy the same space. But there is also a multiplicity of salt pillars, not just one. Along the southern shore, particularly around Mount Sodom, numerous pillars rise from the landscape. Some are named, identified with other figures from the destruction narrative or from later legends that have accumulated around this place. Others are anonymous, unmarked, significant only for their own sake, for their strange beauty, for the way they catch light and cast shadows, for their presence in this landscape of extremes. Walking among them is an otherworldly experience, moving through a terrain where the familiar material of your kitchen table has become the substance of landscape, where salt is not a condiment but bedrock, where the normal hierarchies of mineral importance are inverted. The pillars are fragile despite their size. Rain dissolves them, wind abrades them,
Changes in temperature cause cracking and spalling, yet they persist because the conditions that create them are ongoing. As old pillars erode away, new ones form. The salt mountain itself is constantly losing mass to dissolution while being pushed upward from below by tectonic forces, maintaining its presence even as its surface is renewed. Individual pillars come and go, but the phenomenon of salt pillars has persisted throughout human history in this region, will likely persist for as long as there is salt here and weather to shape it. The symbolism of salt in human culture adds another layer to the significance of these formations. Salt has been precious throughout history, necessary for preserving food, for human health, valuable enough to serve as currency in some cultures. The origin of the word salarium, the salt money paid to Roman soldiers. Salt has been used in religious rituals across many traditions, symbolizing purity, preservation, incorruptibility. The phrase salt of the earth comes from the Christian Gospels, praising those who give flavor and preservation to society. In Jewish tradition, salt is used in kosher food preparation and in ritual contexts, symbolizing the eternal covenant. In Islamic tradition, salt represents hospitality and the obligations created by sharing food. To be turned into salt, then, as Lot's wife was according to the story, is to be transformed into something precious, into something preserving and preserved. It is not simply punishment, but a particular kind of fate, becoming a monument, becoming permanent in a changed form, becoming part of the landscape rather than a traveler through it. The story resonates across cultures and centuries, partly because of this ambiguity, this sense that transformation into salt is both a curse and consecration, both loss and preservation, both death and a strange kind of immortality. The scientific study of the salt pillars and the broader salt formations of the Dead Sea region has revealed information about the sea's history and the processes that shape it. By analyzing the composition of salt from different pillars and different layers within Mount Sodom, researchers can reconstruct periods of different chemical composition in the sea, periods when different minerals were precipitating, periods that correspond to different climatic conditions or different inputs to the sea. The salt is a record, a text written in minerals, and learning to read it provides insights to the past that no written document could provide.
The pillars also demonstrate principles of crystal growth and dissolution that have applications beyond this specific location. How crystals form, how they grow, how they respond to changes in solution chemistry, how they interact with impurities and with each other. All of this is visible and accessible in the Dead Sea's salt formations in ways that are harder to study in other contexts. The Dead Sea becomes a natural laboratory for understanding processes that occur throughout the Earth's crust, wherever water and minerals interact, wherever evaporation concentrates solutions, wherever crystallization occurs. But perhaps most importantly, the salt pillars remain powerful as symbols, as physical manifestations of stories and ideas that transcend geology. They stand as reminders that the earth itself produces wonders, that natural processes can create forms that inspire awe and provoke thought, that the boundary between the natural and the meaningful is porous, that landscape and story inform each other, that what we see depends not just on what is there, but on what we bring to the seeing. The pillar identified as Lot's wife is simultaneously a salt diapier shaped by geological forces and a monument to an ancient story about obedience and loss, about the dangers of looking backward, about the price of longing for what is being destroyed. It is both of these things at once, and the richness comes from holding both understandings together, from allowing the geological reality and the narrative significance to coexist without forcing one to give way to the other.
Standing before these salt pillars, white and gleaming in the harsh sun, you are standing before monuments that are simultaneously ancient and new, permanent and temporary, natural and meaningful. They rise from a sea that is itself saturated with history and meaning, from a landscape that has been fought over and prayed in and fled from and returned to for thousands of years. They are made of one of Earth's most common minerals, yet they appear nowhere else in quite this form, in this profusion, in this context. They are reminders of the extraordinary capacity of natural processes to create beauty and strangeness, to produce forms that capture human imagination, to blur the boundaries between what is and what means, between geology and story, between matter and spirit. The asphalt rises from the depths of the Dead Sea in dark, irregular masses, floating on the surface despite its appearance of solidity, despite the logic that says something so dense-looking should sink rather than float. This is bitumen, natural asphalt, petroleum that has partially weathered and oxidized, transformed from liquid into a semi-solid or solid state. It appears black or very dark brown in chunks that range from small lumps to masses weighing hundreds of kilograms. Ancient observers, seeing these dark formations appearing seemingly spontaneously on the bright surface of the sea, must have found them mysterious, must have wondered at their origin, must have developed stories to explain how and why the sea produced these strange gifts. The geological explanation is complex but understandable. Beneath the Dead Sea, buried under layers of salt and sediment, lie organic-rich deposits laid down millions of years ago when this region had different climate conditions, when vegetation grew more abundantly, when organic matter accumulated in sediments rather than being oxidized and dispersed. Over geological time, buried under accumulating layers of rock, subjected to heat and pressure, this organic matter underwent chemical transformation, breaking down into hydrocarbons, into petroleum products ranging from natural gas through crude oil to heavier compounds like bitumen and asphalt. The Rift Valley's geological activity provides both the conditions that create these petroleum products and the pathways that allow them to migrate to the surface. Faults and fractures that cut through the rock layers create conduits through which gas and liquid can move upward, driven by pressure from below. The asphalt, less dense than the rocks surrounding it, but more dense than water, rises through these conduits until it reaches the Dead Sea floor. There, it seeps out, coming into contact with the water, which further modifies its chemistry, potentially dissolving some lighter components while leaving behind the heavier, more viscous material. This material coagulates into chunks that separate from the sea floor and rise through the dense water to float on the surface where they can be harvested. The harvesting of Dead Sea asphalt is documented from ancient times. Classical authors describe it, noting its value and the methods used to collect it. The historian Josephus, writing in the 1st century CE, mentions the asphalt and describes how it was collected by people who would venture onto the water to retrieve the floating masses. The process was not without risk. The water's high salinity and mineral content could damage skin and eyes. The heat was intense, and the asphalt itself could be difficult to handle, sticky and heavy, requiring careful management to bring to shore. Once harvested, the asphalt had numerous uses. Its waterproofing properties made it valuable for sealing boats and baskets, for protecting structures from moisture, for creating water-resistant coatings on various objects. Its adhesive properties made it useful for hafting tools, for attaching points to arrows and spears, for joining materials that needed to stay joined. Mixed with other ingredients, it could be used in medicines and cosmetics, though the medical theories that justified these uses would not be accepted by modern medicine. The Egyptians imported Dead Sea asphalt for use in mummification, mixing it with other materials to create the substances used to preserve bodies for the afterlife.
The thermal properties of this dense brine also differ from normal water. It holds heat more efficiently, warming under the desert sun and retaining that warmth well into the evening and night. In summer, the surface temperature can reach 35 degrees Celsius or even higher, creating conditions that are bath-like, almost uncomfortably warm. This warmth, combined with the mineral content, has led to the Dead Sea's reputation as a therapeutic destination, a place where the combination of minerals, warmth, and the unique atmospheric conditions at this low elevation create conditions believed to benefit various skin conditions, arthritis, respiratory problems, and other ailments. The ancient world certainly recognized these therapeutic properties. Roman and Byzantine sources describe health resorts along the Dead Sea shores, places where wealthy individuals would come to bathe in the mineral-rich waters, to coat themselves in the mineral-rich mud found along the shores, to breathe the dense, oxygen-rich air of this below-sea-level location. Herod the Great, the builder of Masada and the Second Temple, was said to have bathed in the Dead Sea waters seeking relief from his various ailments. Cleopatra, according to some accounts, valued Dead Sea products highly, even allegedly conquering portions of the region to secure access to the balsam groves and mineral resources around the sea. This medicinal reputation has continued into modern times, creating a wellness industry around the Dead Sea that draws visitors from around the world. Hotels and spas line portions of both the Israeli and Jordanian shores, offering treatments using Dead Sea mud and minerals, providing access to the water itself, promising healing and rejuvenation through exposure to this unique environment. The scientific evidence for many of these claims is mixed. Some conditions do seem to respond positively to Dead Sea therapy, while for others the benefits are less clear. But the belief persists, as it has for millennia, that there is something special about this water, something that goes beyond mere chemical composition, something that makes it not just different, but potentially transformative. The weight of the water manifests in other ways as well, in how it interacts with the environment, how it shapes and is shaped by the landscape around it. When the water level drops, as it has been doing for decades, it leaves behind terraces of salt, layered deposits that mark previous shorelines, creating a staircase of mineral that descends from what was once underwater to what is now exposed to air. These salt formations are fragile yet persistent, dissolving in rain but reforming as the sun evaporates moisture, creating temporary sculptures that change with each weather pattern, each season, each fluctuation in humidity and temperature. The mud of the Dead Sea shore is equally distinctive, a thick black ooze, rich in minerals, formed from the sediments that wash down from the surrounding mountains, mixed with the salts and minerals of the sea itself. This mud has been harvested and packaged and sold for cosmetic use, exported around the world as Dead Sea mud, marketed for its supposed skin benefits, its mineral content, its exotic origin. Whether it has any real therapeutic value beyond what any good quality clay might provide is debatable, but its cultural cachet, its association with this famous location, gives it value in the marketplace of wellness and beauty products. The weight of the water is also historical, metaphorical, the accumulated gravity of millennia of human association with this place. The Dead Sea has been known to humanity for as long as there have been humans in this region, which is to say for tens of thousands of years. Archaeological sites around its shores reveal successive waves of occupation, of people drawn to this harsh yet resource-rich environment, people who learn to exploit its offerings while coping with its challenges. The combination of fresh water springs along the western shore, the salt and other minerals the sea provided, the strategic position within the Jordan Valley system, all made this an important region despite the inhospitable conditions. The weight's heaviness is chemical, physical, historical, mythological. It is the literal weight of dissolved minerals, 34 grams in every 100 grams of water. It is the metaphorical weight of the past, of the stories and struggles that have unfolded along these shores, of the civilizations that have risen and fallen within sight of these heavy waters. It is the weight of expectation, of the reputation that precedes every visitor's first encounter with this famous sea. And it is the weight of mortality, the knowledge that this sea, for all its ancient persistence, is dying in our time, shrinking at a rate that makes its long-term survival uncertain, adding urgency and melancholy to every visit, every study, every contemplation of its strange and heavy waters. The Dead Sea sits within one of Earth's most dramatic geological features, though you might not realize it from ground level, might not grasp the full scale and significance of the rift valley that contains it unless you see it from above or study maps that reveal the larger context. This is part of the Great Rift Valley system, that immense fracture in Earth's crust that extends from Syria in the north through the Jordan Valley, down through the Dead Sea in the Arava Valley to the Gulf of Aqaba, then continues south as the Red Sea, and ultimately splits into the East African Rift, extending all the way to Mozambique. It is one of Earth's most significant geological features, a place where tectonic plates are pulling apart, where the African plate and the Arabian plate are slowly separating, moving at rates measured in millimeters per year, but accumulating over millions of years into movements measured in hundreds of kilometers.
The history of human civilization around the Dead Sea stretches back into the depths of antiquity, back beyond the reach of written records, into that murky period where archaeology and tradition are our only guides. People have lived in this region for thousands of years, drawn by the resources the sea and the surrounding landscape provided, despite the harsh conditions, the intense heat, the scarcity of fresh water, the difficulty of agriculture in such an environment. What drew them? Water, paradoxically. Not the dead waters of the sea itself, but the springs that emerge along the western shore. Fresh water sources rising from aquifers in the mountains above, creating oases where life could flourish, where date palms could be cultivated, where settlements could establish themselves. The archaeological record shows occupation going back to the Chalcolithic period, more than 5,000 years ago, with sites showing evidence of copper smelting, of early metallurgy, of communities that had moved beyond simple subsistence to develop specialized crafts and trade networks. These early inhabitants understood the value of the Dead Sea's salt, likely harvested it for preservation of food and for trade. They may have collected the asphalt as well, using it for waterproofing and adhesive purposes. They built in stone and mud brick, created pottery and tools, buried their dead with grave goods that speak of belief in an afterlife, of social stratification, of cultural sophistication. As centuries passed, the region saw the rise and fall of various cultures and kingdoms: the Canaanites, the Israelites, the Moabites, the Nabateans, all established presences around the Dead Sea, all exploited its resources, all left traces that archaeologists continue to discover and interpret. The sea was always marginal, always on the edge of zones of dense habitation rather than at their center, but it was never irrelevant, never forgotten. Its salt alone ensured its economic importance, and the other resources it provided: asphalt, mineral-rich mud, the strategic position within the broader Rift Valley system gave it significance beyond what its harsh conditions might suggest. The biblical references to the Dead Sea are numerous and significant. The earliest may be the account of the destruction of Sodom and Gomorrah, those cities of the plain whose sins were said to be so grievous that God destroyed them utterly, raining fire and brimstone upon them, transforming their region into desolation. The Genesis account places these cities in the Valley of Siddim, which is the Salt Sea, connecting the cities directly to the Dead Sea. Whether this represents historical memory of actual cities destroyed by some catastrophe, earthquake, volcanic event, or military conquest remains debated. Archaeological surveys have identified possible candidate sites for these cities, ruins along the southeastern shore that date to the appropriate period and show signs of destruction, but definitive identification remains elusive. The story of Lot's escape from these doomed cities, the command not to look back, his wife's disobedience and transformation into a pillar of salt, this narrative has been read and interpreted by billions of people across millennia. It speaks to themes that resonate across cultures: the danger of nostalgia, the impossibility of returning to the past, the price of disobedience, the necessity of moving forward even when you long to look back.
That this story is set at the Dead Sea, that the transformation is into salt specifically, ties it inextricably to this place, makes the sea itself a character in the narrative, a presence that witnesses and preserves, that stands as monument to ancient judgment. Other biblical references place various events around the Dead Sea. David, fleeing from King Saul, hid in the wilderness of En-Gedi, that oasis on the western shore. The boundary descriptions of the Israelite tribal territories frequently mention the Salt Sea as an eastern boundary, a natural landmark that defined the limits of habitable land. The prophet Ezekiel had a vision of water flowing from the temple in Jerusalem eastward to the Dead Sea, transforming its salt waters into fresh, allowing fish to live, creating abundance where there had been desolation. A powerful image of restoration and transformation that has inspired religious thought and environmental activism alike. The Nabateans, that remarkable Arab people who created a trading empire in the centuries before the Roman conquest, certainly used the Dead Sea's resources. Their capital at Petra, though located some distance south of the sea, was connected to it by trade routes. They may have been involved in the asphalt trade, in salt harvesting, in the production of balsam, that valuable aromatic resin that grew in limited areas around the Dead Sea and that commanded high prices in the Roman world. The Nabateans were masters of water management, building cisterns and channels that allowed them to thrive in desert environments, and they would have understood the value of the freshwater springs along the Dead Sea's shores. The Romans, when they conquered this region in the 1st century BCE, recognized the Dead Sea's economic importance. They taxed the asphalt and salt production. They established control over the balsam groves. They built roads and fortifications that secured their access to these resources. Herod the Great, that prolific builder who ruled Judea as a client king of Rome, built palaces and fortresses around the Dead Sea. Most famously, the fortress of Masada, that remarkable complex perched atop a plateau on the sea's western shore. Herod's motivations were partly strategic. Masada was a refuge, a place he could retreat to if his rule was threatened, but also personal. He suffered from various ailments, and he came to the Dead Sea seeking the therapeutic benefits of its waters and climate.
The Jewish-Roman wars of the 1st and 2nd century CE saw the Dead Sea region become a site of resistance and tragedy. After the destruction of Jerusalem and the Second Temple in 70 CE, various groups of Jewish rebels and refugees fled to the wilderness around the Dead Sea. Some went to Masada, where a dramatic siege and mass suicide would create one of the most famous and controversial episodes in Jewish history. Others fled to caves along the sea's western shore, hiding in the maze of canyons and cliffs, some eventually dying there, their bodies and possessions preserved by the arid climate, discovered centuries later by archaeologists who found not just bones, but documents, letters, scrolls, fragments of daily life frozen at the moment of catastrophe. These caves, particularly those near Qumran, would later yield the Dead Sea Scrolls, perhaps the most significant archaeological discovery of the 20th century. But that is a story deserving its own telling, its own careful exploration. For now, it is enough to note that the caves around the Dead Sea have served as refuges for thousands of years, places where people could hide, could preserve valuable objects, could escape persecution or disaster. The climate here is perfect for preservation. The extreme aridity means that organic materials that would decay quickly in more humid environments can survive for centuries or millennia. The caves have acted as natural archives, preserving snapshots of history in ways few other environments can match. The Byzantine period saw Christian communities establish themselves around the Dead Sea, drawn by the region's biblical associations, by the tradition of hermits and ascetics seeking isolation in the desert, by the desire to be near the sites of biblical events. Monasteries were built,
some of which still function today, perched on cliffs or nestled in wadis, their presence a testament to the enduring spiritual significance of this landscape. The Jordan River, flowing into the Dead Sea from the north, became particularly important in Christian tradition as the site of Jesus' baptism, drawing pilgrims from across the Christian world, a practice that continues to the present day. The Islamic conquest in the 7th century CE brought new rulers but did not fundamentally change the Dead Sea's character or use. Muslim tradition also connected the sea to the Lot narrative, preserving and elaborating the stories of the destroyed cities. The sea continued to provide salt and other resources, continued to be crossed by trade routes, continued to be home to small communities that survived by exploiting its margins, by cultivating date palms at oases, by herding goats and sheep in the surrounding hills, by participating in regional trade networks. Crusader fortresses from the medieval period still stand in the region, including some overlooking the Dead Sea, remnants of that violent time when European Christians attempted to establish kingdoms in the Holy Land. These fortifications speak to the continuing strategic importance of the region, the desirability of controlling routes and resources, the way the Dead Sea remains significant as kingdoms and empires rose and fell around it. The Ottoman period, lasting from the 16th century until the First World War, saw the Dead Sea region remain a backwater, sparsely inhabited, occasionally visited by explorers and pilgrims, but largely left to the Bedouin tribes who moved through the region with their flocks, understanding the rhythms of the desert, knowing where water could be found, maintaining traditional patterns of life that had persisted for centuries. The Ottomans were aware of the sea's resources, but did little to exploit them systematically, leaving the salt and asphalt to be harvested by local people for local use rather than developing large-scale extraction. It was only in the 19th century, as European powers became increasingly interested in the region, that systematic study of the Dead Sea began. Explorers mapped its shores, measured its depth, analyzed its water, sent back reports that sparked scientific and popular interest. By the early 20th century, as the Ottoman Empire collapsed and European colonial powers carved up the Middle East, the economic potential of the Dead Sea's minerals was becoming clear. Chemical analysis revealed the extraordinary concentrations of potash, magnesium, bromine, and other industrially valuable elements. The stage was set for the transformation of the Dead Sea from a mysterious natural wonder into an industrial resource, a change that would accelerate dramatically in the decades to come. The history of the Dead Sea is inseparable from the history of the peoples who have lived around it, who have used its resources, who have fought over it, who have been inspired by it, who have feared it and revered it. It is a history written in salt and stone, in the ruins of settlements and fortresses, in the scrolls and artifacts preserved in caves, in the layers of meaning that accumulate around a place over millennia of human presence. The sea itself has remained relatively constant, its basic character unchanged despite fluctuations in size and level. But the human relationship to it has evolved continuously, shaped by changing technologies, changing economic systems, changing religious and cultural frameworks, changing understandings of what the sea is and what it means.
The reason nothing lives in the Dead Sea, or almost nothing, as we shall see, is ultimately a matter of chemistry, of the specific combination of dissolved minerals that makes the water not just inhospitable, but actively hostile to most forms of life. Life requires water, but not all water can support life. The concentration of salts in the Dead Sea is so extreme that it disrupts the basic cellular processes that life depends on. Understanding why requires understanding something of how cells work, how they maintain the delicate balance of internal chemistry that allows them to function. Living cells are separated from their environment by membranes, thin barriers made of lipids and proteins that control what enters and exits the cell. These membranes are selectively permeable, allowing some molecules to pass while blocking others. Water can pass through relatively freely, moving by osmosis from areas of lower solute concentration to areas of higher solute concentration. In a normal environment, cells maintain internal concentrations of various dissolved substances, salts, sugars, proteins, that are carefully regulated to keep the cell functioning properly. If the external concentration of dissolved substances is much higher than the internal concentration, water will flow out of the cell by osmosis, following the concentration gradient, attempting to equalize concentrations across the membrane. In the Dead Sea, the external concentration of dissolved salts is extraordinarily high, far higher than anything cells can maintain internally. Any organism placed in this water faces an immediate osmotic crisis. Water rushes out of its cells, attempting to dilute the external brine. The cells shrivel, their internal processes disrupted, their structures collapsing. For most organisms, this is fatal, and quickly so. Fish placed in Dead Sea water die almost instantly. Most bacteria and other microorganisms cannot survive. Even hardy organisms adapted to salty environments, creatures that live in seawater or in salt marshes, find the Dead Sea far beyond their tolerance limits. The name Dead Sea is thus not metaphorical, but literal. This is water where death, not life, is the default condition. But almost nothing is not the same as absolutely nothing. In recent decades, researchers have discovered that certain extremophile microorganisms can survive in the Dead Sea. Organisms so specialized, so adapted to harsh conditions that they can tolerate even this extraordinary environment. These are primarily halophilic archaea, ancient single-celled organisms that represent one of life's three great domains, distinct from both bacteria and the eukaryotes that include all plants, animals, and fungi. These halophiles, salt lovers, have evolved specialized mechanisms for dealing with high salt concentrations. Some accumulate compatible solutes inside their cells, organic molecules that balance the external salt concentration without disrupting cellular functions. Others have proteins and cellular machinery that function normally even in high salt conditions, unlike the proteins of most organisms which denature and lose function in such environments. These microorganisms do not make the Dead Sea alive in any conventional sense. They exist in extremely low numbers compared to normal aquatic ecosystems. They do not form visible communities or create the kind of biological productivity that characterizes lakes and oceans. They are invisible to the casual observer, detectable only through careful scientific sampling and analysis. Yet their presence is significant because it demonstrates that life, given enough time and selection pressure, can adapt to almost anything, can find ways to survive even in environments that seem utterly inhospitable. The halophiles of the Dead Sea are among Earth's most extreme extremophiles, pushing the boundaries of where and how life can exist. The chemistry that makes the Dead Sea so hostile involves not just the quantity of dissolved salts, but their specific composition. As mentioned earlier, magnesium chloride dominates, making up more than half of the dissolved solids. Magnesium salts are particularly harsh on living tissues, more so than sodium chloride. They draw water from cells more aggressively. They interact with proteins and cellular membranes in disruptive ways. They create conditions that even salt-tolerant organisms struggle with. The combination of high magnesium with high concentrations of calcium, potassium, and sodium creates a multi-stress environment where organisms must cope with multiple challenges simultaneously, where adaptation to one stressor does not necessarily confer protection against the others. The mineral composition also affects how the water tastes, though tasting Dead Sea water is emphatically not recommended. Those who have accidentally ingested small amounts report that it is intensely bitter, far more unpleasant than seawater, with a chemical harshness that lingers. The bitterness comes primarily from the magnesium salts, which have a distinctive bitter flavor. The oily, slick feeling of the water comes from the same chemistry, from how these mineral ions interact with organic molecules, with skin, with anything they contact.
This same chemistry that excludes life is what gives the Dead Sea some of its most valuable properties, particularly for preservation. Organic materials that would decay rapidly in normal water can be preserved for extended periods in Dead Sea water or in the brine-soaked sediments of its shores. The high salt concentration inhibits the bacteria and fungi that normally decompose organic matter. The harsh chemistry kills any microorganisms that might attempt to colonize and break down organic materials. This preservation property was recognized in ancient times, though not understood in modern chemical terms. It is why Dead Sea salt and brine were used in food preservation, why they were valued for maintaining the freshness of perishable goods.
The preservation extends to human bodies. There are historical accounts of bodies recovered from the Dead Sea that showed little decomposition despite having been in the water for extended periods. The salt acts as a preservative, much as it does in deliberate mummification, drawing out moisture, preventing bacterial decay, maintaining structures that would otherwise break down. This property has occasionally been exploited in criminal cases, where bodies disposed of in the Dead Sea have been recovered in surprisingly good condition, allowing forensic analysis that would be impossible if the bodies had been in freshwater or on land. The chemistry of the Dead Sea also affects the archaeological record. Sites near the Dead Sea, particularly those in the dry climate of the surrounding desert, show remarkable preservation of organic materials. Wood, leather, textiles, papyrus, parchment, all survive far better here than in most environments. This is partly due to the arid climate, but the presence of salt also plays a role, killing microorganisms, inhibiting decay processes, maintaining organic structures. This preservation is why the Dead Sea Scrolls survived for 2,000 years, why leather sandals and woven baskets and wooden artifacts from ancient times can be found in caves around the sea, often in astonishingly good condition. The chemistry of the Dead Sea has changed over time, not in its basic character but in specific details. The northern and southern basins, now largely separated by human intervention, have different compositions. The northern basin, deeper and more directly connected to the Jordan River's inflow, is less saline than the southern basin, which is shallower and more subject to evaporation. These differences create gradients in mineral concentration, variations in chemistry from place to place and depth to depth. The sea also shows seasonal and longer-term variations in composition, responding to changes in inflow, evaporation rates, and other factors. Modern industrial exploitation has significantly affected the sea's chemistry. The extraction of minerals, particularly potash and magnesium, removes dissolved salts from the water, changing concentrations and ratios. The diversion of fresh water that would naturally flow into the sea reduces the dilution effect that periodic floods would have had, allowing salts to concentrate even further. The separation of the northern and southern basins has created conditions where the two parts of what was once a single sea are evolving along different chemical trajectories, potentially leading to even more distinct compositions in the future. The lack of life in the Dead Sea also means the lack of certain processes that are fundamental to most aquatic ecosystems. There is no photosynthesis occurring in the water, no primary production by algae or other photosynthetic organisms. There is no food web, no predators and prey, no cycling of nutrients through biological processes. The Dead Sea is a purely chemical and physical system, governed by evaporation and precipitation, by dissolution and crystallization, by processes that belong to geology and chemistry rather than to biology. This makes it simpler in some ways than normal ecosystems, easier to model and predict, but also alien, fundamentally different from the living waters that cover most of Earth's surface. Yet this apparent simplicity is deceptive. The chemistry of the Dead Sea is actually quite complex, with multiple salts in dynamic equilibrium, with stratification and mixing patterns that vary seasonally and over longer periods, with interactions between the water and the underlying sediments, with exchanges of gases between water and atmosphere.
Understanding this chemistry requires sophisticated analytical techniques and complex mathematical models. Predicting how the chemistry will respond to changing conditions, to continued water diversion, to mineral extraction, to climate change is challenging, with significant uncertainties remaining despite decades of study. The chemistry also creates beauty, strange chemical beauty that appears in the colors and textures of the water and shores. The water's color shifts with mineral concentrations, with suspended particles, with the angle of sunlight and the depth of the water. Sometimes it is deep blue, almost purple. Sometimes it is milky turquoise, clouded with minerals in suspension. Sometimes it shows reddish or pinkish tones, particularly in shallow areas where certain mineral combinations interact with light in specific ways. The shores are painted in gradients of white salt, brown mud, gray stone, creating abstract compositions that seem more like paintings than photographs, more like art than nature. This chemistry of death, this hostile mineralized water, is also what makes the Dead Sea unique, what makes it valuable, what makes it worth studying and preserving. A living sea, a normal body of water with fish and plants and the usual biological processes, would be less interesting scientifically, less significant economically, less mysterious culturally. It is precisely the Dead Sea's lifelessness, its extreme chemistry, its deviation from the norm that makes it extraordinary. The absence of life becomes, paradoxically, what gives the Dead Sea much of its meaning, what makes it a place that draws scientists and tourists, religious pilgrims and industrial operations, photographers and poets, all seeking to experience or understand or exploit this unique manifestation of water transformed by minerals into something that is simultaneously familiar and utterly strange.
The fortress of Masada rises from the desert floor like a vision of defiance rendered in stone, a flat-topped mountain that stands alone, isolated from the surrounding terrain, accessible only by narrow, winding paths that climb its sheer faces. From the shores of the Dead Sea, which lies just a few kilometers to the east, Masada is visible as a distinctive silhouette against the sky, a geometric form that is obviously artificial in its flatness, obviously shaped by human hands despite its massive scale. It is, simultaneously, one of the most dramatic archaeological sites in the world and one of the most emotionally charged, a place where ancient architecture and tragic history combine to create an experience that transcends mere tourism or academic interest. Herod the Great built Masada in the 1st century BCE, creating a palace complex and fortress that served multiple purposes. Refuge in case of rebellion, pleasure palace where he could escape Jerusalem's political intrigues, demonstration of his wealth and power, strategic stronghold controlling routes in the Judean desert. The location was chosen for its defensive qualities. The plateau top is approximately 450 meters long and 300 meters wide, large enough for significant construction but small enough to be defensible. The cliffs on all sides rise between 180 and 450 meters above the surrounding terrain, creating natural walls that would be nearly impossible for an army to scale. Herod's architects and engineers created something extraordinary on this isolated plateau. They built palaces with elaborate mosaics, painted frescoes, bathhouses with heated floors and running water. They constructed vast cisterns carved into the rock and plastered to hold water, capable of storing enough water to sustain a population through long sieges. They built storerooms for food, armories for weapons, living quarters for soldiers and servants. They created, in essence, a self-contained city in the sky, a place that could be sealed off from the world and survive independently, at least for a time. The palace complex itself is a marvel of ancient architecture. The northern palace, built on 3 terraces descending down the northern cliff face, is particularly remarkable. The upper terrace contained living quarters and a semicircular balcony offering views of the surrounding desert and the Dead Sea. The middle terrace, some 20 meters below, was circular, designed for entertaining, with columns supporting a roof, decorated with frescoes in the Roman style. The lowest terrace, another 15 meters down, contained a bathhouse and additional entertainment spaces, columns painted to resemble marble, walls covered with frescoes depicting architectural elements, creating illusions of grandeur and space. The engineering required to build on these steep slopes, to create stable platforms at different levels, to manage water and drainage, demonstrates sophisticated technical capability. But Masada's fame rests less on Herod's architectural achievement than on what happened there decades after his death during the First Jewish-Roman War. In 70 CE, after the Romans destroyed Jerusalem and the Second Temple, a group of Jewish rebels fled to Masada, taking control of Herod's abandoned fortress. These were Sicarii, zealots named for the small daggers they carried, extremists who had played a controversial role in the rebellion, known for both their fierce resistance to Rome and their willingness to use violence against fellow Jews they viewed as collaborators. For several years, the rebels held Masada, perhaps 960 people, including women and children, according to the historian Josephus, our primary source for these events. They lived in Herod's palace, used his cisterns, ate from his storehouses. They were cut off, isolated, the last holdouts of a rebellion that had been crushed elsewhere, but they were also secure, protected by Masada's natural defenses, capable of holding out indefinitely as long as their supplies lasted and the Romans chose not to besiege them seriously. But Rome did choose to besiege Masada, assigning the 10th Legion under the command of Flavius Silva to take the fortress, to eliminate this last pocket of resistance, to demonstrate that Roman power could not be defied anywhere under any circumstances. The Roman army, thousands of soldiers supported by thousands more enslaved laborers, surrounded Masada, established camps at its base, began the slow, systematic work of siege warfare. They built a siege wall entirely around the plateau, ensuring no one could escape, no supplies could enter. Then they began constructing a ramp, an enormous earthen embankment on the western side, where the cliff is lowest, building it gradually higher, pushing it up the slope toward the plateau top, creating a path by which siege engines and troops could reach the fortress. The construction of this ramp was an engineering achievement in its own right, requiring thousands of tons of earth and stone, requiring precise engineering to maintain stability on the steep slope, requiring months of labor under the desert sun. The defenders on Masada could do little to stop it, though they must have watched its progress with increasing desperation, must have known that once the ramp reached their walls, once the Romans brought up their battering rams and siege towers, the end would come inevitably. Masada's defenses were designed to prevent enemies from climbing the cliffs, not to withstand siege engines operating at the same level as the fortress walls. According to Josephus, when the Romans finally breached the walls, they found that the defenders had chosen suicide over surrender. The leader, Eleazar ben Yair, had convinced the others that death in freedom was preferable to slavery under Rome, that they should kill themselves and their families rather than fall into Roman hands. 10 men were chosen by lot to kill all the others. Then they drew lots again to choose one who would kill the remaining 9 before killing himself. When the Romans entered the fortress, they found only silence and death. 960 bodies, the entire community self-slaughtered rather than accepting defeat. This story, as Josephus tells it, has become central to modern Israeli identity, a narrative of resistance and martyrdom, of choosing death over subjugation, of defiance maintained to the ultimate extreme.
The phrase, "Masada shall not fall again," has become a motto, the site itself a place of national pilgrimage, where Israeli soldiers are sometimes sworn in, where the ancient tragedy is invoked as inspiration and warning. The historical accuracy of Josephus's account is debated. He was not present at Masada. He had his own agendas and biases. His sources are unknown. Archaeological evidence confirms the siege, confirms the Roman camps and ramp, confirms violent destruction in the final assault. But whether the mass suicide occurred exactly as described, whether Josephus embellished or simplified, whether the defenders' motivations were as noble as the account suggests, remains uncertain.
What is certain is that Masada, seen from the shores of the Dead Sea, remains a powerful presence, a monument that speaks across 2,000 years. The palace Herod built for pleasure became the site of tragedy. The cisterns that stored water for luxury now remind us of desperation and siege. The storerooms built to hold years of supplies were emptied by people with nowhere left to run. The fortress designed to be impregnable was breached, and its defenders chose an end that has echoed through history. The relationship between Masada and the Dead Sea is visual and symbolic. From Masada's heights, the sea spreads below, brilliant and alien, a presence that must have been constantly visible to the defenders during their final months, a reminder of the larger landscape they inhabited, of the strange geology and chemistry that characterized their refuge. The sea's barrenness mirrors the desert surrounding Masada, both environments hostile to normal life, both places where survival requires special adaptation or determination. The sea's persistence, its presence unchanged by human drama, must have offered some strange comfort or perhaps bitter reminder. The sea would remain long after the fortress fell, long after everyone involved in this tragedy had died, long after Rome itself had fallen, the heavy waters continuing their slow evaporation, the minerals continuing their patient accumulation, indifferent to human struggle. Today, visitors who climb to Masada, either by the snake path, that narrow trail that winds up the eastern cliff, or by cable car for those less adventurous or able, find ruins that have been extensively excavated and partially reconstructed. You can walk through Herod's palace, see the mosaics and frescoes, visit the bathhouse and storerooms. You can stand on the northern terrace and look out over the desert and the Dead Sea, seeing what Herod saw, what the defenders saw, what the Roman soldiers saw as they completed their ramp. The view is extraordinary, vast and stark, a landscape that seems to exist outside of time, where the ancient and the modern collapse into a single present moment. The Dead Sea has changed since Masada's time. Its level has dropped significantly, exposing shores that were underwater 2,000 years ago, changing the visual relationship between the fortress and the sea. But the essential character remains. The sea is still there, still gleaming, still strange, still part of the experience of visiting this place, still providing context for understanding why this location was chosen, why it could be defended so long, why it remains so powerful in memory and imagination. Masada is one of many archaeological sites around the Dead Sea, but it is perhaps the most famous, certainly the most visited, the one that has most captured public imagination. It represents the intersection of geography and history, of natural landscape and human drama that characterizes this entire region. The Dead Sea does not merely provide a backdrop for human events, it shapes them, influences them, becomes part of them. The same geology that created the sea created the fortress platform. The same aridity that concentrates the sea's salts preserved the archaeological remains. The same strategic position that made the sea valuable made Masada defensible. Everything connects, landscape and history inseparable, each giving meaning to the other.
In the spring of 1947, a Bedouin shepherd named Muhammad Ed-Dib, searching for a lost goat in the cliffs northwest of the Dead Sea, threw a stone into a cave and heard the unexpected sound of breaking pottery. Investigating, he discovered ancient jars containing scrolls, manuscripts written in Hebrew and Aramaic, preserved for nearly 2,000 years in the dry atmosphere of the cave. This accidental discovery would prove to be one of the most significant archaeological finds of the 20th century, revolutionizing understanding of ancient Judaism, providing the oldest known manuscripts of biblical texts, offering unprecedented insight into the religious and cultural world of Second Temple period Judaism. The scrolls were preserved by the specific environmental conditions of the Dead Sea region. The caves where they were hidden are extremely arid, rainfall is minimal, and the dry air rapidly evaporates any moisture. The temperature fluctuations are significant between day and night, but overall the climate is stable, with no prolonged periods of high humidity that would promote decay. The salt-rich environment also helps preservation by inhibiting microbial growth. Organic materials, parchment, papyrus, leather, linen, that would decay within years or decades in most environments can survive for millennia here, desiccating rather than decomposing, becoming brittle but remaining intact. The scrolls themselves vary in preservation condition. Some are remarkably complete, entire columns of text legible, leather or parchment in good enough condition to be unrolled and photographed. Others are fragmentary, degraded by time and by less than ideal storage conditions, requiring painstaking conservation work to separate layers, to identify text, to match fragments with others that might belong to the same document. Yet even these fragments can be valuable, sometimes preserving text that appears nowhere else, sometimes confirming or contradicting other sources, always adding to the mosaic of understanding about the ancient world.
The identity of the people who wrote and deposited the scrolls has been debated extensively. The prevailing theory connects them to the Essenes, a Jewish sect described by ancient historians like Josephus and Philo, known for their ascetic lifestyle, their communal living, their strict observance of purity laws, their apocalyptic beliefs. The ruins at Qumran include structures consistent with communal living: a dining hall, ritual baths, a scriptorium where manuscripts might have been copied, storage rooms, cisterns for water. The settlement appears to have been occupied during the Second Temple period, from roughly the 2nd century BCE to 68 CE, when it was destroyed during the First Jewish-Roman War, probably by the same 10th Legion that later besieged Masada. The theory suggests that the Qumran community, sensing the approaching destruction, hid their library in caves, intending to retrieve it after the danger passed. But the community was destroyed or dispersed, the scrolls remained hidden, and only chance, a shepherd's lost goat, a thrown stone, revealed them 2,000 years later. This narrative has dramatic appeal and fits much of the evidence, but it is not without problems and alternatives. Some scholars question whether the scrolls came from Qumran or were brought from Jerusalem or elsewhere. Others debate whether Qumran was a religious community at all, or rather a commercial or military installation. The debates continue, with new evidence and new arguments regularly appearing in scholarly literature. Regardless of their precise origins, the scrolls' significance is immense. They include the oldest known manuscripts of almost every book of the Hebrew Bible, predating previously known copies by 1,000 years or more. Comparing these ancient texts with later manuscripts reveals how the biblical text was transmitted across centuries, showing both remarkable stability in some books and significant variations in others. The scrolls also include books that were not included in the canon, texts that were read and revered by some Jewish groups, but ultimately not preserved in the mainstream tradition. Reading these texts provides insight into the diversity of Second Temple Judaism, the range of beliefs and practices that existed before the destruction of the temple and the subsequent consolidation of Rabbinic Judaism.
The sectarian documents are perhaps even more fascinating, offering direct access to the thoughts and concerns of an ancient religious community. The community rule describes how the group organized itself, its membership requirements, its punishments for violations of rules, its theological beliefs. The War Scroll describes an apocalyptic final battle between the Sons of Light and the Sons of Darkness, mixing military strategy with theological speculation. The Copper Scroll, unique among the finds, is inscribed on copper rather than written on parchment, and lists locations of buried treasure, perhaps real caches hidden by the temple priesthood before the Roman destruction, perhaps wishful thinking or literary fiction. The mystery of the Copper Scroll's treasure has inspired searches and speculation, but so far no confirmed discoveries. The biblical commentaries, called Pesherim, are also significant. They interpret biblical texts as prophecies referring to their own time, identifying biblical figures with contemporary people and events, finding hidden meanings in the ancient texts. This method of interpretation, while foreign to modern historical critical reading, was common in the ancient world and provides insight into how these texts were read and understood by their contemporaries. The connection between the Dead Sea Scrolls and the Dead Sea itself is more than coincidental proximity. The scrolls survived because of the Dead Sea's climate, the extreme aridity and stable conditions that characterize the region. The settlement at Qumran existed where it did partly because of the Dead Sea's presence, providing salt and possibly other resources, while the cliffs and caves nearby offered places for retreat and meditation, for the kind of isolation and ascetic life that the community apparently valued. The theological worldview preserved in the scrolls shows influence of the desert and the Dead Sea. Images of dryness and water, of wilderness and cultivation, of barrenness and fertility appear throughout the texts, metaphors drawn from the immediate environment. The process of finding, acquiring, conserving, translating, and publishing the scrolls has its own dramatic history, involving international intrigue, scholarly controversies, accusations of deliberate delays and suppressed information, legal battles over ownership, and finally, in recent decades, the gradual making available of high-quality images and translations to scholars and the public. The international team that initially controlled access to the unpublished scrolls became increasingly controversial for their slow progress, leading to pressure that eventually resulted in the release of photographs and the expansion of the scholarly community working on the texts. Today, complete collections of images and translations are available online, democratizing access in ways unimaginable to the first generation of scroll scholars. The conservation challenges are ongoing. The scrolls, having survived 2 millennia in caves, now face different threats in museums and laboratories. Light exposure can cause fading and degradation. Fluctuations in temperature and humidity can cause physical stress. Even the act of unrolling and photographing scrolls can damage them. Modern conservation techniques, including climate-controlled storage, specialized photography that minimizes light exposure, digital imaging that allows study without handling originals, all help preserve these irreplaceable documents. But time continues to take its toll, and there's a race between degradation and the effort to capture every readable character before it fades.
The Dead Sea Scrolls have changed our understanding of the ancient world, providing direct evidence for beliefs and practices that were previously known only through later, potentially biased sources. They have also generated enormous public interest, inspiring exhibitions that draw large crowds, documentaries that introduce their discovery and significance to mass audiences, and unfortunately also pseudo-archaeological speculation that misuses the scrolls to support various fringe theories. Separating solid scholarship from sensationalism remains an ongoing challenge. From the caves above Qumran, you can look down at the Dead Sea, can see what the ancient sect members saw, the strange inland sea stretching southward, the mountains of Jordan rising beyond, the landscape of extremes that formed their world. The connection between the scrolls and the sea is visible, tangible, a reminder that texts and contexts are inseparable, that to understand what people wrote, you must understand where and how they lived,
what they saw and experienced daily, how their environment shaped their thought. The Dead Sea, in this as in so many other ways, is more than geological phenomenon or chemical curiosity. It is part of human history, part of the story of how people have thought and believed and written, part of the heritage preserved in its arid margins for those who come later to discover and attempt to understand. The shoreline of the Dead Sea is retreating, pulling back from hotels and roads and infrastructure built when the water was higher, exposing mudflats and salt plains that expand year by year, transforming the geography of the region in ways that are dramatic and troubling. The rate of retreat is extraordinary, averaging more than a meter per year in recent decades, creating a situation where beaches that existed within living memory are now hundreds of meters from the water's edge, where piers and docks extend uselessly over dry land, where the distance between what was and what is grows wider every season. The cause is well understood. The Dead Sea's water budget is severely negative, with evaporation vastly exceeding inflow. In the pre-modern past, this imbalance was corrected by the Jordan River, which brought enough water to replace what evaporated, maintaining the sea's level within a range that fluctuated seasonally and over longer climate cycles, but remained relatively stable. But the Jordan's flow into the Dead Sea has been reduced to a trickle, diverted for agriculture and drinking water by Israel, Jordan, and Syria, captured in dams and canals that prevent it from reaching its historical terminus. The Sea of Galilee, which feeds the Jordan, is itself stressed by water demands. The result is that the Dead Sea now receives perhaps 5 to 10% of the Jordan's historical flow, not nearly enough to balance evaporation. The industrial extraction of minerals also affects the water balance. The chemical plants operated by Israeli and Jordanian companies pump Dead Sea water into evaporation ponds, deliberately evaporating it to crystallize out potash, magnesium, and other valuable minerals. This is commercial evaporation on top of natural evaporation, further depleting the sea's water. The industry argues that their impact is less than that of agricultural diversion, which is true in volume terms, but the cumulative effect of all water losses is pushing the sea toward crisis. As the water level drops, the consequences cascade through the environment and the human communities around the sea. The most dramatic and dangerous consequence is the formation of sinkholes, sudden collapses of the ground that can swallow trees, roads, buildings, creating zones of instability that have forced the abandonment of previously developed areas. These sinkholes form through a specific mechanism. As the Dead Sea's level drops, the boundary between the salty groundwater beneath the shore and the fresh water flowing in from surrounding aquifers changes. The fresh water, now able to reach areas previously saturated with brine, dissolves salt layers, creating voids. Eventually, the ground above these voids collapses, forming sinkholes that can be meters or tens of meters across, appearing suddenly and without warning. Thousands of sinkholes have formed around the Dead Sea in recent decades, clustered particularly along the western shore, where conditions are most favorable for their formation. Areas that were previously safe are now hazardous, marked with warning signs, fenced off, evacuated. Roads have been rerouted, buildings abandoned, tourist facilities closed. The sinkholes continue to appear, and predicting exactly where the next one will form is difficult, making large areas around the sea effectively uninhabitable. The environmental consequences extend beyond sinkholes. The exposed mudflats and salt plains create dust problems, with wind picking up fine particles and carrying them inland, affecting air quality and health. The change in shoreline affects whatever limited ecosystems exist around the sea. The freshwater springs that once emerged at or near the waterline are now far from the water, creating isolated pools rather than the transitional zones between fresh and salt that previously existed. These springs support unique ecosystems, the oases where date palms grow, where wildlife congregates.
But the changing geography is altering these systems in ways not yet fully understood.
The economic impact on the tourism and spa industries is significant. Hotels built on what was the shore now stand far from the water, requiring guests to take shuttle buses or trains to reach beaches. Some facilities have had to close entirely, unable to adapt to the changing geography. Investment in tourism infrastructure becomes uncertain when you cannot predict where the waterline will be in a decade. The region's economic development, which depends partly on the unique characteristics of the Dead Sea and the wellness tourism it attracts, is threatened by the very degradation of the resource it depends on. Various proposals have been advanced to address the crisis, but all face significant challenges. The most ambitious is the Red Dead project, which would involve building a canal or pipeline from the Red Sea in the south to the Dead Sea, using the elevation difference to generate hydroelectric power while replacing the lost water. This project has been studied extensively with environmental impact assessments, engineering feasibility studies, economic analyses. It would be enormously expensive, one of the largest infrastructure projects in the region. It raises environmental concerns about mixing Red Sea water with Dead Sea water, potentially altering the Dead Sea's chemistry in unpredictable ways. It also involves complex political considerations, requiring cooperation between Israel, Jordan, and the Palestinian Authority, navigating issues of sovereignty and resource sharing. A similar proposal, the Med-Dead Canal, would bring water from the Mediterranean rather than the Red Sea. This route is shorter, but lacks the elevation difference that makes the Red Dead project energetically favorable. Both proposals also raise concerns about what bringing in large quantities of outside water would do to the Dead Sea's unique chemistry, whether it would dilute the distinctive characteristics that make the sea valuable, whether the cure might be worse than the disease. More modest proposals focus on reducing water diversion from the Jordan River, allowing more water to flow naturally to the Dead Sea. This would require difficult political and economic decisions about water allocation, about agricultural practices, about regional cooperation on shared water resources. Water is precious in this arid region, and every cubic meter diverted to the Dead Sea is water that cannot be used for other purposes. Yet, without some restoration of Jordan River flow, the Dead Sea's decline will likely continue, with all the environmental and economic consequences that entails. Some voices argue for accepting the Dead Sea's shrinkage, adapting to it rather than trying to reverse it, perhaps even allowing it to split into separate bodies of water, or to shrink to a much smaller remnant. This perspective sees the attempts at large-scale intervention as hubristic, potentially doing more harm than good, and suggests that resources would be better spent on adaptation, managing sinkholes, relocating infrastructure, reimagining the region's economic basis, rather than on megaprojects with uncertain outcomes. The debate over the Dead Sea's future involves science, economics, politics, and values. It raises questions about human responsibility to natural systems, about whether and how we should intervene in environmental processes, about how to balance competing human needs and uses of resources. It also involves questions about heritage and identity, about what it means for a feature as ancient and symbolically significant as the Dead Sea to disappear or be radically transformed within a few human generations. Standing at the current shoreline, looking at the exposed mudflats that extend where water once was, seeing the marks of previous water levels on nearby cliffs, recognizing how dramatically the geography has changed within living memory, brings home the reality that the Dead Sea is not eternal despite its ancient persistence. It is a product of a specific balance between inflow and evaporation, and when that balance is disrupted, the sea responds, shrinking toward a new equilibrium that may be very different from what has existed for millennia. The heavy waters are becoming less heavy in absolute terms, the volume declining even as the concentration intensifies. The sea becoming smaller, but in some ways more extreme,
more purely itself as it contracts toward an uncertain future. The emotional weight of witnessing this decline is difficult to capture in words. For people who have lived their lives near the Dead Sea, who remember when the water lapped against shores that are now dry, who have watched familiar landmarks move farther from the water's edge year after year, the change is not abstract environmental data, but lived experience, personal loss. The sea is part of identity, part of how people understand their place and their history. To watch it shrink is to watch a piece of your world diminish, to confront the reality that even the most ancient and seemingly permanent features can be vulnerable to human actions, can be lost through choices about water allocation and industrial development, choices made incrementally over decades without full understanding of their cumulative impact. For religious communities, the Dead Sea carries spiritual significance that makes its decline even more poignant. This is the sea mentioned in biblical texts, the setting for stories that have shaped faith and identity for millions. The idea that it might cease to exist or be transformed beyond recognition raises uncomfortable questions about stewardship, about human responsibility to creation, about whether this generation has the right to destroy or fundamentally alter something that has existed since ancient times and that carries meaning beyond its physical presence.
Scientists studying the Dead Sea face their own form of urgency. The sea is a unique natural laboratory, an extreme environment whose characteristics make it valuable for research into numerous questions about chemistry, geology, climate history, and extreme life. If it disappears or is fundamentally altered, that scientific value is lost. There is also the concern that interventions designed to save the sea, like the proposed Red Dead Canal, might change its character so much that what is saved is no longer really the Dead Sea, but something new, something different, created by engineering rather than by natural processes. The sinkholes, beyond their danger and the property damage they cause, have become symbols of the broader environmental crisis. They are dramatic, photogenic in a terrifying way, creating images that communicate the problem more visibly than graphs of declining water levels. A photograph of a sinkhole that has swallowed a road or a building tells a story immediately, viscerally, in ways that technical reports cannot. These sinkholes have thus become focal points for environmental activism, for efforts to raise awareness and motivate action, for campaigns to save the Dead Sea before it's too late. Yet there is also a fatalistic current in some discussions, a sense that perhaps it is already too late, that the forces depleting the Dead Sea are too entrenched, too economically and politically important, too tied to the basic survival needs of millions of people in a water-scarce region to be reversed. This fatalism asks whether we are witnessing the end of the Dead Sea as it has existed for millennia, whether our generation is the one that will see it disappear or transform into something unrecognizable, whether we are living through an extinction event for a body of water. But extinction may be too strong a word. Bodies of water do not die in the way organisms die. They change, they shrink or grow, they alter in character, but some remnant usually persists. The Dead Sea will not suddenly vanish completely, leaving only dry land where water once lay. More likely is a future where it shrinks to a much smaller size, perhaps splits into multiple pools, becomes even saltier as it contracts, becomes even more extreme in its characteristics. It might become something more like the small hypersaline lakes found in other desert regions, interesting and extreme, but no longer the vast inland sea that has been a landmark of the Middle East for millennia. The historical precedent for such transformations exists. The Aral Sea in Central Asia, once one of the world's largest lakes, has shrunk to a fraction of its former size due to water diversion for irrigation, splitting into smaller bodies of water, leaving behind vast salt flats and creating environmental catastrophe.
The parallels to the Dead Sea are sobering, a warning of what can happen when human water use disrupts the balance that maintains a terminal lake. Yet the Aral Sea disaster has also mobilized conservation efforts, created awareness of the consequences of unsustainable water use, potentially offering lessons that could inform Dead Sea management. The economic calculations surrounding the Dead Sea's future are complex. The mineral extraction industry generates significant revenue and employment, contributing to the economies of both Israel and Jordan. The tourism and wellness industries also generate substantial economic activity. Both sectors depend on the Dead Sea, but in different ways and with different long-term interests. The mineral companies can, in theory, continue extracting even from a much smaller sea, perhaps even preferring higher concentrations that come with shrinkage. The tourism industry needs the sea to remain accessible and dramatic, needs beaches and infrastructure that can be used by visitors, needs the iconic experience of floating in the Dead Sea to remain available. These economic interests sometimes align and sometimes conflict, creating complicated politics around water management and conservation. Agricultural interests in the Jordan Valley compete for water that might otherwise flow to the Dead Sea. Farms using Jordan River water produce valuable crops, support rural communities, contribute to food security. Telling farmers they must use less water so that the Dead Sea can be maintained involves difficult choices about priorities, about whose needs take precedence, about how to balance environmental conservation with economic development and human welfare. The geopolitics add another layer of complexity. The Jordan River Basin and the Dead Sea itself cross international borders, with Israel, Jordan, Syria, and the Palestinian territories all having interests and claims. Regional cooperation on water management exists, but is fragile, subject to political tensions, to historical conflict, to competing national interests. The Dead Sea cannot be saved by any one party acting alone. It requires coordinated action, shared commitments, mutual trust. In a region where these qualities are often in short supply, achieving the level of cooperation necessary for effective Dead Sea management is profoundly challenging. Climate change introduces additional uncertainty. The Middle East is projected to become hotter and drier in coming decades, with reduced rainfall and increased evaporation. This could accelerate the Dead Sea's decline, even if human water diversions are addressed, could make restoration more difficult or impossible, could push the region toward a water crisis that makes current problems seem manageable by comparison. Planning for the Dead Sea's future must account not just for current conditions, but for changing climate, for a world where water scarcity intensifies, where demands on limited resources increase, where the challenges facing the Dead Sea become part of a larger pattern of environmental stress across the region.
Yet there are also grounds for hope, or at least for believing that complete disaster is not inevitable. Awareness of the Dead Sea's crisis has grown, both locally and internationally. Conservation organizations have made it a priority. UNESCO has considered World Heritage status, which could bring resources and attention. The economic value of preserving the Dead Sea as a tourist attraction and natural wonder is increasingly recognized, potentially shifting calculations toward conservation. Technologies for water conservation, for desalination, for efficient irrigation continue to improve, potentially allowing the region's water needs to be met while still allowing some flow to the Dead Sea. Perhaps most importantly, there is growing recognition that the Dead Sea is not just a local issue, but a global one, part of the world's natural heritage, a place of scientific, historical, and spiritual significance that transcends national boundaries. This recognition could motivate international support for conservation efforts, could help fund the expensive interventions that might be necessary to stabilize the sea's decline, could create political pressure on regional governments to prioritize preservation. The receding shoreline, for all its negative implications, has also revealed things that were previously underwater, exposing archaeological sites, geological formations, features that add to our understanding of the region's history and formation. In this sense, the crisis is also an opportunity, a chance to learn things that could not be learned when these areas were covered by water, to document and study before they are lost to other processes or before water potentially returns. The Dead Sea's future remains uncertain, balanced between forces of decline and efforts at preservation, between economic pressures and environmental values, between the momentum of current trajectories and the possibility of intentional intervention. What is certain is that the sea we see today is not the sea our children may see. That change is occurring on timescales much shorter than the geological processes that created this remarkable body of water. That human actions are now the dominant factor shaping its fate. The heavy waters are still here, still strange and wonderful, still worth experiencing and preserving, but their persistence into the future is not guaranteed. Depends on choices yet to be made, on whether this generation can find the will and the way to protect something ancient and irreplaceable before it's gone. The extraction of minerals from the Dead Sea represents one of the most significant economic activities in the region, a modern industry built upon ancient recognition that these waters contain valuable substances. But where ancient peoples harvested salt by hand, carrying away what they could use or trade in small quantities, modern operations extract minerals on industrial scales, using technologies and processes that transform vast volumes of water into chemical products sold around the world. The primary target of extraction is potash, a term referring to various potassium-containing compounds, particularly potassium chloride. Potash is essential for modern agriculture, used in fertilizers that provide the potassium plants need to grow. Global demand is substantial, driven by the need to feed growing populations, to increase crop yields, to support intensive agricultural systems. The Dead Sea contains approximately 50 billion tons of dissolved salts, with significant percentages of that being potassium salts, making it one of the world's richest sources of this valuable mineral. The extraction process involves pumping Dead Sea water into vast evaporation ponds, shallow basins covering hundreds of square kilometers, where the water is left to evaporate under the intense desert sun. As evaporation proceeds, different minerals crystallize out in sequence, determined by their solubility. Sodium chloride, the most abundant salt but less valuable industrially, crystallizes first and is often discarded or used for other purposes. The remaining brine becomes progressively enriched with magnesium, potassium, and other minerals. Eventually, potassium chloride begins to crystallize, at which point it is harvested, processed, purified, and prepared for sale. This process consumes vast quantities of water. Not consumes in the sense of destroying it, since water doesn't disappear, but removes it from the Dead Sea, accelerating evaporation that would have occurred anyway, but concentrating it in controlled ponds rather than letting it happen from the sea's natural surface. The companies operating these facilities argue that their impact on the Dead Sea's level is modest compared to the effect of Jordan River diversion, which is true in absolute volume terms. But their operations certainly contribute to the water deficit, and they also alter the chemistry of the southern basin, which is now largely separated from the northern basin and used primarily for industrial purposes. Magnesium is another important product extracted from Dead Sea water. Magnesium compounds have numerous industrial applications, from fire retardants to cement production to pharmaceuticals. The Dead Sea's high magnesium content makes it an attractive source, with extraction operations producing various magnesium products, including magnesium chloride, magnesium bromide, and metallic magnesium. The extraction technology is more complex than for potash, requiring more processing, more energy input, more sophisticated chemical engineering, but the value of the products justifies the investment. Bromine, Another element found in significant concentration in the Dead Sea is extracted and used in flame retardants, in agricultural chemicals, in pharmaceuticals, in industrial processes. Dead Sea bromine operations represent a significant portion of global bromine production, making this region important to industries worldwide that depend on this element. The extraction process involves treating Dead Sea brine with chemicals that release elemental bromine, which is then captured and processed. The industrial operations around the Dead Sea are substantial, visible from space, transforming the landscape in ways that are dramatic and controversial. The evaporation ponds appear as geometric patterns of different colors: white, blue, pink, depending on mineral concentrations and algae growth, creating landscapes that look artificial, which they are, but that also possess a strange beauty in their regularity and in the intensity of their colors. Aerial photographs and satellite images of these ponds have become iconic, appearing in photo collections and environmental campaigns, illustrating both human capacity to reshape landscapes and the environmental costs of industrial extraction. Employment and economic benefits from these industries are significant for the region. The extraction facilities employ thousands of people directly, with additional jobs in supporting industries and services. The companies pay taxes, invest in infrastructure, support community programs. For economically developing regions, particularly in Jordan, these industries represent important sources of income and development. Decisions about Dead Sea conservation cannot ignore these economic realities, cannot simply shut down operations without addressing what would replace the jobs and revenue they generate. Yet, the long-term sustainability of these operations is questionable if the Dead Sea continues to shrink. The industries depend on a certain volume of water being available, on the ability to pump water into evaporation ponds, on maintaining infrastructure that connects facilities to the sea. If the Dead Sea splits into multiple smaller bodies of water or shrinks below certain levels, the logistics of extraction become more difficult, potentially more expensive, potentially eventually impossible in current forms. The companies recognize this and have generally supported efforts to stabilize the Dead Sea's level, seeing it as necessary for their own long-term interests. The southern basin of the Dead Sea, where much of the industrial activity is concentrated, is now maintained artificially, with water pumped from the northern basin to keep the southern basin filled. Without this pumping, the southern basin would dry out, becoming salt flats rather than water. This pumping is expensive but necessary for industrial operations, representing a subsidy of sorts that the companies pay to maintain the resource they extract from. The arrangement is peculiar, an industry that contributes to depleting the sea, also working to maintain it, at least in the portions crucial to their operations, creating a complex relationship between extraction and conservation. Historically, mineral extraction from the Dead Sea is ancient, though on much smaller scales than modern operations. Salt harvesting goes back millennia, with evidence of organized salt trade in the Bronze Age and earlier. The value of salt in the ancient world, for food preservation, for religious ritual, for various practical applications, made Dead Sea salt a valuable commodity. The ease of harvesting it, simply collecting crystallized salt from the shores or evaporating water in small ponds, made it accessible even with pre-industrial technology. Asphalt harvesting, as discussed earlier, was another form of ancient mineral extraction, valuable enough to merit mention in classical sources, important enough to be controlled by kingdoms and to generate trade across regions. The medicinal mud, rich in minerals, was another product harvested and valued in ancient times, used in treatments for various ailments, exported to distant markets. Modern extraction is different in scale, but not entirely different in kind. It represents continuity, a recognition that the Dead Sea contains valuable materials, that these materials can be harvested and used, that the economic benefits justify the effort.
What has changed is the technology, allowing extraction on scales that would have been unimaginable to ancient harvesters, and the awareness of environmental consequences, understanding that large-scale extraction cannot continue indefinitely without affecting the source. The companies involved have increasingly invested in sustainability initiatives, in water conservation technologies, in research into reducing their environmental footprint. Public relations considerations motivate some of this, but there is also genuine recognition that the long-term health of their industry depends on the Dead Sea's persistence, that destroying the source would be self-defeating. Whether these initiatives are sufficient, whether they can offset the ongoing water deficit, whether they represent meaningful change or merely greenwashing remains debated. The global market for Dead Sea minerals introduces another dimension. Products extracted from the Dead Sea are sold worldwide, used in agriculture in the Americas, in manufacturing in Asia, in cosmetics in Europe. The Dead Sea is thus connected to global economic systems, to supply chains that span continents, to markets that influence pricing and demand. Decisions about extraction levels, about environmental protection, about water allocation have implications that extend far beyond the immediate region, affecting prices and availability of products used by millions of people who may never see the Dead Sea, who may not even know where their fertilizers or flame retardants originate.
The cosmetics industry has also embraced the Dead Sea, marketing products that contain Dead Sea minerals that claim therapeutic or beautifying properties. The trade on the exotic reputation and ancient associations of this famous body of water. Dead Sea mud masks, mineral-rich creams, salts for bathing, these products fill shelves in stores around the world, often sold at premium prices, often with marketing that emphasizes purity, natural origins, ancient wisdom. The scientific evidence for many claimed benefits is thin, but the cultural cachet is real and the market is substantial. The Dead Sea becomes brand, becomes marketing tool, becomes commodity in ways that raise questions about exploitation, about cultural appropriation, about who profits from natural resources and ancient associations. The workers in these industries, the people who actually labor in the extraction facilities, in the evaporation ponds, in the processing plants, have their own perspectives on the Dead Sea, shaped by daily contact, by economic dependence, by lived experience that differs from tourists or scientists or environmentalists. For them, the Dead Sea is workplace, is source of livelihood, is the landscape of daily routine rather than occasional visit. Their voices are often absent from discussions about the Dead Sea's future, but their interests and their knowledge are relevant, should inform decision-making about how this resource is managed. The mineral harvesting, past and present, represents humanity's long relationship with the Dead Sea as resource, as source of materials that can be extracted and used elsewhere, converted into economic value, transformed from natural phenomenon into commodity. This relationship is neither simply good nor simply bad, but complex, involving benefit and cost, creation and destruction, wealth generation and environmental degradation. Understanding this complexity is necessary for thinking honestly about the Dead Sea's future, for making decisions that acknowledge both the legitimate human uses of these resources and the need to preserve something irreplaceable, for finding balance between extraction and conservation, between economic development and environmental protection. The therapeutic reputation of the Dead Sea extends back into ancient times, with historical references to its healing properties, to people coming specifically to bathe in its waters or to apply its mud in treatment of various ailments.
This reputation has only grown in modern times, supported by scientific studies that have documented genuine medical benefits for certain conditions, creating a wellness tourism industry worth hundreds of millions of dollars annually, drawing visitors from around the world seeking relief from skin conditions, arthritis, respiratory problems, and general stress. The combination of factors that make the Dead Sea therapeutically valuable is unique and not fully replicated anywhere else. The water's mineral composition, rich in magnesium, calcium, potassium, and bromides, is absorbed through the skin during bathing, potentially affecting various physiological processes. The mud, formed from minerals and sediments, has different composition and properties, applied topically as treatment for skin conditions and joint pain. The atmospheric conditions at this low elevation, higher atmospheric pressure, lower ultraviolet radiation levels, higher oxygen content, create an environment that some studies suggest benefits respiratory function, and that allows longer sun exposure without the same risk of burning that exists at higher elevations. Psoriasis, a chronic skin condition causing red, scaly patches, shows particularly good response to Dead Sea treatment. Multiple clinical studies have documented improvement in psoriasis symptoms following periods of Dead Sea therapy, with many patients experiencing significant clearing of lesions. The treatment typically involves daily bathing in the Dead Sea, exposure to sunlight, and application of Dead Sea mud, sometimes combined with other therapies. The mechanism is not fully understood, but may involve the minerals' effects on skin cell growth and immune function, combined with the beneficial effects of controlled sun exposure. Atopic dermatitis and other skin conditions also respond positively to Dead Sea treatment, though evidence is less robust than for psoriasis. The minerals may help reduce inflammation, improve skin barrier function, affect the populations of microorganisms that colonize skin. The mud has been shown to have anti-inflammatory properties, possibly explaining its traditional use in treating various skin ailments. The high salt content may also have antimicrobial effects, reducing bacterial and fungal populations that can exacerbate skin conditions. Arthritis and rheumatic conditions have been treated at the Dead Sea for decades, with patients reporting improvement in pain and mobility. The mechanism may involve several factors. The buoyancy of the water reduces stress on joints, allowing exercise and movement that would be painful on land. The warmth of the water may reduce joint stiffness. The minerals absorbed through skin may have anti-inflammatory effects. The overall relaxation and stress reduction associated with spa treatment may reduce symptoms exacerbated by stress and tension. Respiratory conditions, particularly asthma, are sometimes treated with Dead Sea therapy, though the evidence base is smaller. The theory is that the high atmospheric pressure and lower allergen levels at this elevation benefit respiratory function, that breathing the oxygen-rich air helps improve lung capacity and reduces symptoms. Some clinics combine Dead Sea therapy with more conventional respiratory treatments, creating integrated approaches that address multiple factors affecting respiratory health.
The psychological benefits of Dead Sea spa treatment should not be discounted. The dramatic landscape, the unique experience of floating effortlessly, the removal from daily routines and stresses, the focused attention on health and well-being. All of these contribute to effects that may be therapeutic regardless of the specific mineral content or atmospheric conditions. The placebo effect, while often dismissed, is real and can produce genuine improvements in symptoms and quality of life. If people feel better after Dead Sea treatment, if their symptoms improve, if their quality of life increases, then the treatment has value, regardless of whether we fully understand the mechanisms. The modern spa and wellness industry around the Dead Sea has grown substantially, with facilities ranging from basic hotels offering access to the water to luxury resorts providing comprehensive spa services, medical supervision, specialized treatments. The Israeli side of the Dead Sea has been developed more intensively for tourism, with a string of hotels and spas along portions of the western shore.
The Jordanian side has also developed tourism infrastructure, particularly near the town of Suema, where the majority of Jordan's Dead Sea hotels are concentrated. Both sides market themselves to international wellness tourism, attracting visitors from Europe, Russia, the Americas, Asia, all seeking the therapeutic benefits and the unique experience this location offers. The medical tourism aspect is particularly significant in Israel, where specialized clinics treat patients with psoriasis and other skin conditions, often in programs lasting several weeks, combining Dead Sea therapy with conventional medical treatments. These programs are sometimes covered by health insurance from European countries, recognizing Dead Sea therapy as legitimate medical treatment for certain conditions. This medical recognition gives the tourism industry additional legitimacy, moving it beyond mere spa relaxation into the realm of actual healthcare. However, the declining water level and sinkholes pose increasing challenges for this industry. Hotels that were once on the shore now require shuttle buses to transport guests to beaches. Some facilities have had to close due to sinkhole danger or because the retreating water made operations impractical. Investment in new tourism infrastructure is risky when the geography is changing so rapidly. The industry thus has a strong motivation to support efforts to stabilize the Dead Sea's level, seeing its own survival as tied to the sea's survival. The marketing of Dead Sea wellness products globally has created a boom in cosmetics and skincare products claiming to contain Dead Sea minerals, often marketed with emphasis on natural ingredients, ancient traditions, and therapeutic benefits. The science supporting many of these claims is limited, but the marketing is effective, trading on the Dead Sea's reputation and mystique. Some products genuinely contain substantial amounts of Dead Sea minerals. Others contain minimal amounts or even substitute other mineral sources while trading on the Dead Sea name. Regulation of these claims varies by jurisdiction, and consumers often have little way to verify whether products actually contain what they claim. The tradition of mud application deserves particular attention. Visitors to the Dead Sea invariably engage in the ritual of covering themselves in black Dead Sea mud, photographing themselves and each other caked in mineral-rich ooze, then rinsing off in the sea. This practice is part tourism ritual, part therapeutic treatment, part social media content creation. The mud is collected from various locations around the shore and sold commercially, or visitors collect it themselves from accessible deposits. The experience is tactile, playful, transgressive in the way it encourages adults to become covered in mud like children. But it also connects participants to an ancient practice, to the historical use of Dead Sea mud for healing, to traditions that extend back millennia. Scientific research into Dead Sea therapeutic properties continues, with studies examining specific mechanisms, testing effectiveness for various conditions, comparing Dead Sea treatment to conventional therapies. This research is complicated by methodological challenges, difficulty in creating proper control groups, challenges in isolating specific factors. Is it the minerals, the atmosphere, the sun exposure, the relaxation, or some combination? The influence of expectation and belief on outcomes. But the body of evidence is gradually growing, providing firmer foundation for claims of therapeutic benefit, while also clarifying which benefits are well supported and which remain speculative or unproven. The future of Dead Sea wellness tourism depends partly on the sea itself surviving in accessible form, partly on continued scientific validation of therapeutic claims, partly on economic factors affecting international travel and medical tourism. The industry has shown resilience despite challenges, adapting to changing conditions, investing in facilities that can continue operating even as the shoreline retreats. But there are limits to adaptation, points beyond which the Dead Sea experience may become so diminished or difficult to access that the tourism industry cannot sustain itself in current forms. The healing waters tradition represents another dimension of humanity's relationship with the Dead Sea, another way this body of water has been valued beyond its chemical composition or geological interest. The Dead Sea heals, or is believed to heal, or provides context for healing,
offering relief to suffering bodies, providing respite from chronic conditions, creating space for recovery and restoration. This therapeutic dimension adds to the arguments for preservation, gives the Dead Sea value measured not in mineral extraction revenues, but in human health and well-being, in the relief of pain, in the improvement of quality of life. These values are harder to quantify economically, but no less real, no less important in considering what this sea means and why its loss would matter.
Ein Gedi appears like a miracle along the barren western shore of the Dead Sea, a burst of green in a landscape otherwise dominated by browns and grays and the brilliant white of salt, a place where water flows year-round, where vegetation flourishes, where wildlife congregates in contrast to the emptiness surrounding it. The springs of Ein Gedi rise from aquifers in the mountains above, water that fell as rain on the Judean hills percolating through limestone, emerging at this location where geological formations create conditions for springs to surface. The water is fresh, sweet, drinkable, the opposite of the Dead Sea's bitter brine that lies just hundreds of meters away. The name Ein Gedi means Spring of the Kid, referring to the ibex that inhabit this region, wild goats that climb the cliffs and congregate near the springs to drink. These ibex, with their curved horns and sure footing, have become symbols of Ein Gedi, appearing in countless photographs, watched by visitors who hike the trails that wind through the reserve. They are wary but habituated to human presence, maintaining distance but tolerating observers, moving through the rocky terrain with grace that seems effortless, adapted perfectly to this harsh environment. The oasis created by Ein Gedi's springs has supported human habitation for thousands of years. Archaeological sites in and around Ein Gedi show occupation extending back to the Chalcolithic period, more than 5,000 years ago, with successive periods of habitation continuing through biblical times, through Roman and Byzantine periods, into the Islamic period and beyond. The water made settlement possible, allowing agriculture, supporting date palms and other crops, providing the most essential resource in this desert environment. Biblical references to Ein Gedi are numerous and significant. The most famous is the story of David hiding in the caves of Ein Gedi while fleeing from King Saul, an episode recorded in 1 Samuel. Saul, hunting David with an army, entered a cave to relieve himself, unaware that David and his men were hiding in the cave's recesses. David crept close enough to cut a corner from Saul's robe, proof that he could have killed the king but chose not to, demonstrating his loyalty despite Saul's persecution. This story, set explicitly at Ein Gedi, connects the oasis to one of the Hebrew Bible's central narratives, to the story of David's rise to kingship, to themes of mercy and restraint and divine protection. The Song of Solomon mentions Ein Gedi in a metaphor comparing the beloved to a cluster of henna blossoms in the vineyards of En Gedi. This reference associates Ein Gedi with beauty, with fertility, with the lush growth made possible by its waters. Henna was cultivated at Ein Gedi in ancient times, along with date palms and the famous balsam, an aromatic plant that produced resin used in perfumes and medicines, highly valued in the ancient world, and cultivated in only a few locations, Ein Gedi being among the most famous. The balsam of Ein Gedi was renowned throughout the ancient world. Classical authors described it, noting its value and the care taken in its cultivation. The resin was extracted by making cuts in the bark, allowing the sap to seep out where it was collected. The process required skill and knowledge, understanding when and how to cut to maximize production without harming the plant. The resulting resin was processed and sold at high prices, used in perfumes, in medicines, in religious ceremonies.
Cleopatra was said to have been particularly fond of Ein Gedi balsam, and legends claim she even instigated wars to gain control of the balsam groves. The true identity of this ancient balsam is uncertain. The plant, whatever it was, no longer grows at Ein Gedi or anywhere else in the region. It may have been harvested to extinction, or climate changes may have made the region unsuitable for its growth, or political upheavals may have disrupted the knowledge necessary for its cultivation. Modern botanists have speculated about which plant it might have been, with various candidates proposed, but definitive identification remains elusive. This loss represents one of many cases where ancient agricultural products, perfectly adapted to specific locations and carefully cultivated over generations, were lost when the cultural knowledge maintaining them was broken. Today, Ein Gedi is a nature reserve, protecting the springs, the wildlife, the unique ecosystems that flourish in this oasis. Hiking trails lead through the reserve, following streams that descend from the springs, passing waterfalls that cascade over rock faces, leading to pools where visitors can swim in fresh water before walking the short distance to float in the Dead Sea's salt water, experiencing both extremes of the aquatic spectrum within a single visit. The contrast is dramatic, moving from fresh mountain water to the densest, saltiest water on Earth within a few hundred meters, within minutes of walking. The vegetation at Ein Gedi includes species that are rare or absent elsewhere in the region. Date palms, their fronds creating shade and their fruit providing food, grow in groves near the springs. Reeds and rushes fill the stream channels. Acacia trees, tamarisks, and other desert-adapted species cluster where their roots can reach water. In spring, when winter rains have been adequate, wildflowers bloom, adding colors to the dominant greens and browns, attracting insects and birds, creating brief periods of abundance before the long, dry summer returns. The bird life is particularly rich, with Ein Gedi serving as an important stopping point for migratory species using the Rift Valley as a flyway between Africa and Eurasia. Hundreds of species have been recorded at Ein Gedi, from tiny warblers to large raptors, from waterfowl using the streams and pools to desert species adapted to the surrounding badlands. For birders, Ein Gedi is a prime destination, offering chances to see species rare or absent elsewhere in the region, to observe migration phenomena, to study how different species adapt and exploit this unusual environment. The contrast between Ein Gedi's verdant oasis and the Dead Sea's barren shores just below emphasizes the importance of fresh water in this region, the difference that flowing water makes, the line between habitability and desolation. This contrast has shaped human history here, determining where people could settle, where agriculture was possible, where life could be sustained. The oases along the Dead Sea's western shore, Ein Gedi being the largest and most famous, were the primary sites of permanent settlement, the places where fresh water springs made long-term habitation feasible. The geology that creates Ein Gedi's springs is part of the larger geology of the Dead Sea region. The limestone and dolomite formations that make up the Judean hills are porous and permeable, allowing water to infiltrate and move through them. Where these formations are cut by the steep escarpment that descends to the Dead Sea, where specific geological structures create pathways for water to emerge, springs form. Ein Gedi is the largest such spring system along the western shore, but there are others, smaller but still significant, each creating its own micro-habitat, its own zone of green in the brown desert.
The water quality at Ein Gedi is excellent, filtered naturally by its passage through limestone, cool and clear, good for drinking without treatment. This water has sustained visitors for millennia, has filled the water bottles and canteens of travelers crossing the Dead Sea region, has irrigated gardens and crops, has made possible the human presence that has persisted here through all the changes of history and politics. The reliability of these springs, their year-round flow, regardless of season, makes them particularly valuable in a region where most water sources are intermittent, flowing only after rains, dry for most of the year. The future of Ein Gedi, like much else around the Dead Sea, faces uncertainty. Climate change projections suggest reduced rainfall in this region, which could affect the aquifer recharge that feeds the springs, potentially reducing flow or even causing springs to fail. The dropping level of the Dead Sea itself affects the gradient between the springs and the sea, potentially impacting how water moves through the geological formations, how springs behave. The formation of sinkholes near Ein Gedi has required closure of some areas, rerouting of trails, constant monitoring for new collapses. Yet Ein Gedi persists, as it has persisted for thousands of years, a green jewel set against the harsh backdrop of desert and salt, a place of refuge and beauty, of water and life, of contrast and surprise. It represents the resilience of natural systems, the way life finds footholds even in harsh environments, the value of small pockets of habitability in landscapes otherwise hostile to most organisms. It also represents continuity, connection across time, the same water that refreshed David and his men still flowing, still creating oases, still supporting wildlife, still drawing visitors to experience the miracle of fresh water in the desert, sweet water beside the bitter sea, green life at the edge of sterile salt. The Dead Sea is, paradoxically, not actually a sea, but a lake, specifically a terminal lake, meaning it has no outlet. Water flows into it from the Jordan River and from smaller streams and springs, but no water flows out. The only way water leaves the Dead Sea is through evaporation, that constant process by which the intense desert sun converts liquid water into vapor, lifting it into the atmosphere and carrying it away on winds, leaving behind the minerals that were dissolved in the water. This terminal character is fundamental to understanding the Dead Sea, to understanding how it became so salty, why its level fluctuates, what its long-term fate might be. All lakes that lack outlets and that exist in regions where evaporation exceeds precipitation tend toward high salinity. The Great Salt Lake in Utah, the Caspian Sea, which is also actually a lake despite its name, the Dead Sea itself, all are terminal lakes. All have accumulated salts over long periods, all face similar dynamics of water balance and mineral accumulation. The naming of this body of water reflects some of this confusion about its nature. Dead Sea is a translation of the Arabic Bar al-Mayit, or the Hebrew Yam HaMavet, both emphasizing the absence of life. But other names have been used. The Salt Sea, emphasizing its mineral content, Lake Asphaltites, emphasizing its asphalt seepages, the Sea of Lot, connecting it to biblical narrative, the Sea of the Araba, locating it geographically in the larger Rift Valley system. Each name emphasizes different aspects, different understandings of what this body of water is and what makes it significant. The Dead Sea's hydrology is relatively simple in principle, but complex in detail. Water enters primarily from the Jordan River, with additional smaller inputs from springs and occasional wadis that flow during rare rainfall events. Water leaves entirely through evaporation, which in this extreme environment is substantial, averaging about 1.5 meters per year from the water surface. The balance between inflow and evaporation determines the sea's level. When inflow exceeds evaporation, the level rises. When evaporation exceeds inflow, as is the current case, the level falls. Historically, this balance fluctuated but averaged roughly neutral over long periods, with wet years and wet periods bringing higher levels, dry years and dry periods bringing lower levels, but overall maintaining the sea within a range that was relatively stable over centuries and millennia. The natural variability was substantial. The sea's level has varied by hundreds of meters over geological time, but within the period of human observation and record-keeping, the sea showed fluctuations that were notable but not catastrophic.
The current situation represents a break from this historical pattern, an anthropogenic forcing that has pushed the system far outside its normal range of variation. The diversion of Jordan River water is the primary cause, reducing inflow to a tiny fraction of historical levels, creating a water deficit that the sea cannot make up from other sources. The result is the rapid decline in level discussed earlier, with all its ecological and economic consequences. The stratification of the Dead Sea is another important aspect of its hydrology. For much of the 20th century, the sea consisted of two layers, a lower layer of very dense, salt-saturated water, and an upper layer that was less dense, less saline, fed by the Jordan River's relatively fresh water. These layers did not readily mix because of the density difference, creating a stable stratification. The lower layer was essentially stagnant, unchanging for decades, while the upper layer responded to seasonal and longer-term variations in inflow and evaporation.
In the late 1970s, this stratification broke down. The upper layer had been becoming progressively more saline due to reduced Jordan River inflow and continued evaporation. Eventually, it became dense enough that it could sink, mixing with the lower layer, creating a single mixed water column. This overturn was a dramatic event, changing the Dead Sea's physical characteristics, affecting its chemistry, altering how it responds to environmental forcing. The sea is now relatively well mixed, though some stratification develops seasonally, and there are still differences between the northern and southern basins. The salt composition varies somewhat between the northern and southern basins, and at different depths. The northern basin, deeper and more directly connected to Jordan River inflow when that occurred, is slightly less saline than the southern basin. The southern basin, shallow and isolated, more directly affected by industrial ponds and industrial activities, has different mineral ratios, different characteristics. These differences are growing as the two basins become increasingly separated, potentially leading to a future where they are functionally separate bodies of water rather than parts of a single sea. The boundary between the northern and southern basins is now largely artificial, controlled by dikes and canals that manage water flow for industrial purposes. Historically, the two basins were connected naturally, with water flowing between them as levels fluctuated. The current arrangement, with the southern basin maintained by pumping water from the north, represents a fundamental alteration of the sea's natural hydrology, creating conditions that would not exist without human intervention. The seasonal cycle of the Dead Sea shows some variation, though less than normal lakes because the Jordan River's flow, even when it was larger, varied less than the rivers feeding most lakes. Winter brought higher flows, summer lower flows, creating modest seasonal fluctuations in level and in the sea's surface conditions. Now, with Jordan River flow so reduced, the seasonal signal is weaker, overwhelmed by the longer-term trend of decline. The Dead Sea's response to climate variations over longer timescales is recorded in its sediments, in the cores that scientists extract and analyze. These cores show layers of different minerals deposited in different conditions, creating a record that extends back hundreds of thousands of years. Reading this record requires drilling cores through hundreds or thousands of meters of accumulated material, then analyzing each layer, determining its age, its composition, what it reveals about the conditions when it was deposited. This work is painstaking, technical, requiring specialized equipment and expertise, but the rewards are substantial. Access to information about the past that exists nowhere else, insights into how this region's climate has changed over time, clues to understanding natural variability and long-term trends. The Dead Sea's boundaries are harsh and clear, where salt water meets fresh water, where water meets air, where the mineral-saturated zones meet areas where normal life can function. These boundaries define what can live where, creating sharp transitions rather than gradual shifts. The springs along the shore create these boundaries dramatically visible, with green vegetation ending abruptly where salt-encrusted soil begins, where the spring's influence ends and the Dead Sea's dominance takes over.
The lake that was called a sea will remain in some form for the foreseeable future. Even under worst-case scenarios of continued water diversion, complete elimination of Jordan River flow, continued industrial extraction, the lowest parts of the Dead Sea Basin will retain water, will continue to accumulate runoff from occasional storms, will continue to be a place where water flows in and evaporates away. What may disappear is the Dead Sea as we know it, the large body of water covering more than 600 square kilometers, the sea that has existed through recorded history, the sea mentioned in ancient texts and depicted on old maps. That sea is dying, shrinking, transforming into something different, and whether it can be saved or must be allowed to transform is the central question confronting this generation's relationship with this ancient body of water. The layers of salt and sediment that accumulate on the Dead Sea's floor are not merely geological deposits, but archives of history, records written in minerals that preserve information about past climates, past environments, past conditions in this region, extending back further than any human record can reach. Reading these archives requires drilling cores through hundreds or thousands of meters of accumulated material, then analyzing each layer, determining its age, its composition, what it reveals about the conditions when it was deposited. This work is painstaking, technical, requiring specialized equipment and expertise, but the rewards are substantial. Access to information about the past that exists nowhere else, insights into how this region's climate has changed over time, clues to understanding natural variability and long-term trends.
The cores extracted from the Dead Sea bed contain alternating layers of different materials. Some layers are primarily halite, sodium chloride, indicating periods of high evaporation and low freshwater input. Other layers are richer in aragonite, a form of calcium carbonate that precipitates under different conditions, or gypsum, calcium sulfate. Still other layers contain more typical lake sediments, clays and silts washed in from surrounding watersheds, organic materials from the sparse life that existed in less saline periods. The sequence of these layers creates a stratigraphy, a geological column that can be read like pages in a book, though a book written in a language that requires translation, interpretation, careful analysis to understand. Dating these layers requires multiple techniques. Radiocarbon dating can be applied to organic materials in younger sediments, providing ages back about 50,000 years. For older materials, other techniques must be used. Uranium series dating, magnetic stratigraphy, comparing the orientation of magnetic minerals to known changes in Earth's magnetic field, correlating distinctive layers to events dated elsewhere. The result is a chronology, not always precise, but sufficient to place layers in time, to know which deposits formed during ice ages, which during warmer periods, which during specific centuries or millennia. The climate information preserved in these layers is detailed and valuable. Layers with lower salt content, with more typical lake sediments, indicate periods when the climate was wetter, when more rain fell in the watershed, when the Jordan River carried more water, when the Dead Sea was larger, deeper, less saline. These periods correspond to ice ages, to times when global climate shifts affected regional precipitation patterns, bringing more moisture to the Middle East. The layers from these periods often contain traces of life: pollen from plants that grew around a larger, less salty lake, shells of gastropods or other organisms that could tolerate the lower salinity, organic remains that would not preserve in fully saline conditions. Layers with high salt content, with thick deposits of halite, indicate opposite conditions: periods of extreme aridity, of reduced precipitation, of lower Jordan River flow, of a smaller, saltier, more concentrated sea. These periods often show no traces of life, just pure evaporite minerals, the accumulated residue of evaporation dominating over any other process. The thickness of these layers indicates how long the conditions persisted, how severe the aridity was, how much the sea shrank during these crisis periods. The most extreme layers,
indicating periods when the Dead Sea may have dried up entirely or nearly so, are controversial and intensely studied. Did the sea completely desiccate during the worst dry periods, leaving behind salt flats that later refilled when wet conditions returned? Or did it always maintain some water body, even if much smaller than today's sea? The evidence is ambiguous, with different researchers interpreting the same cores differently, with debates continuing about what specific layers indicate. But the possibility that the Dead Sea has dried up before, has experienced even more extreme conditions than today's crisis, is sobering and relevant to understanding its vulnerability and resilience. The cores also preserve evidence of earthquakes, of tectonic activity that continues to affect the Dead Sea region. Earthquake events can cause underwater slumping, creating layers of disturbed sediment, mixed materials that interrupt the normal sequence of deposits. These earthquake layers can sometimes be dated and correlated with historical accounts of seismic events, connecting the geological record with written history, providing independent evidence for events mentioned in texts, sometimes revealing earthquakes that left no trace in written records, but that affected the region nonetheless. Chemical analysis of the core samples reveals shifts in mineral composition that reflect shifts in water chemistry, in the balance of different salts, in the sources of water entering the sea. Isotopic analysis, measuring the ratios of different isotopes of oxygen, carbon, and other elements, provides information about temperature, about evaporation rates, about the sources of water, about biological processes. These isotopic signatures are sensitive indicators of environmental conditions, preserving information that the gross mineral composition might not reveal. The correlation between the Dead Sea cores and other climate archives, ice cores from polar regions, marine sediment cores from oceans, cave deposits from other locations, allows researchers to place the Dead Sea's history in global context, to see how regional climate changes relate to larger patterns, to understand the teleconnections between different parts of Earth's climate system. When a layer in the Dead Sea indicates extreme drought, do cores from other regions show corresponding changes? Do these events correlate with variations in solar output, with volcanic eruptions that affected global climate, with shifts in ocean currents or atmospheric circulation patterns? Building these correlations helps construct more complete pictures of past climate, helps identify causes and effects, helps understand the mechanisms driving climate variability. The comparison between the Dead Sea's recent history, as recorded in the top layers of sediment cores, and the historical period known from written records and archaeological evidence, provides a crucial test of how well we can interpret the cores. If the cores show changes we know occurred, the medieval warm period, the Little Ice Age, historical droughts mentioned in texts, then we can have more confidence that deeper, older parts of the cores are being interpreted correctly. These calibrations are essential for pushing interpretations further back in time, for using the cores to reconstruct climate before the advent of written records.
The Dead Sea's sediment record is particularly valuable because it is continuous and relatively undisturbed. Unlike many lake cores that show gaps where erosion removed sediments or where deposition stopped for periods, the Dead Sea's cores provide a nearly complete record, layer upon layer accumulating without major interruptions, preserving the full sequence of changes over hundreds of thousands of years. This completeness makes the Dead Sea one of the most important continental climate archives, comparable in value to the deep ocean sediment cores and ice cores that are cornerstones of paleoclimate research. But the cores also reveal human impact, the anthropogenic changes that begin to appear in the most recent sediments. The declining deposition rates as Jordan River flow decreased, the changing mineral compositions as industrial extraction affected water chemistry, the abrupt shifts that correspond to known human interventions. All of these appear in the cores, marking the transition from natural climate-driven variability to human-forced changes.
Future cores, if they are ever drilled, will show even more dramatic human signatures, recording the period when the Dead Sea shrank rapidly, when its character transformed, when the system shifted into a new state driven by human actions rather than natural climate variations. The geological time written in salt and sediment extends far beyond human timescales, beyond historical memory, beyond the span of civilizations. It reaches back into the deep past, into times when this region looked nothing like it does today, when different climates prevailed, when the ancestors of modern humans were just beginning their long journey towards civilization. The cores connect us to this deep time, remind us that the conditions we consider normal, the climate we've known through recorded history, are merely one point in a long continuum of variations, that stability is temporary, that change is the only constant. Reading these geological texts humbles us, placing our brief moment in vast context, reminding us that we are newcomers to a world that has been changing long before we arrived and that will continue to change long after we are gone. The Romans knew the Dead Sea, traded for its products, established military and administrative control over the region during their centuries of dominance in the Middle East. But their interest went beyond mere control of a territorial asset. The Dead Sea provided specific products that the Roman economy valued, resources that could be exploited and exported to feed the empire's appetite for luxury goods, medicinal substances, and strategic materials. Understanding Roman interaction with the Dead Sea illuminates not just ancient history, but also the long human tradition of viewing this sea as a resource to be exploited, a pattern continuing to the present day. Balsam was perhaps the most valuable Dead Sea product from the Roman perspective, a substance that commanded extraordinary prices in Roman markets, that was gifted to emperors, that appeared in medical texts as a remedy for various ailments, that was used in cosmetics by the wealthy, that was burned as incense in religious ceremonies. The cultivation of balsam was concentrated in a few areas around the Dead Sea, with Ain Gedi being the most famous production site, but Jericho and other locations also contributing. The Romans understood the economic value of controlling balsam production, exerting tight control over the groves, taxing production heavily, sometimes taking direct ownership of plantations. The exact species of plant that produced this ancient balsam remains uncertain, as mentioned earlier, but its value is undisputed. Josephus describes it, mentioning how valuable it was and how carefully controlled. Pliny the Elder, in his Natural History, discusses the Dead Sea's balsam, its properties, its uses, its value. The fact that multiple classical authors mentioned it attests to its importance and fame throughout the Roman world. The loss of this plant, this valuable resource that no longer exists, represents a significant gap in our understanding of ancient agriculture and economy. Asphalt from the Dead Sea was another commodity that interested the Romans. While they had access to other asphalt sources, Dead Sea asphalt had a reputation for quality, was readily accessible once the region came under Roman control, was exported to Egypt and elsewhere for use in various applications. The Romans themselves used asphalt in construction, in waterproofing, in various industrial and military applications. Controlling Dead Sea asphalt production added to the economic value of the region from Rome's perspective. Salt was another product, less exotic than balsam or asphalt, but more essential to daily life. Dead Sea salt could be harvested easily, was of high quality, could be transported and traded throughout the region. The Romans taxed salt production and trade, recognizing it as a staple commodity, whose value came from necessity rather than luxury, a product everyone needed and therefore a reliable source of revenue. The integration of Dead Sea salt into Roman trade networks meant that this product from one of the lowest places on Earth might end up in markets in Rome itself, carried across sea and land by the elaborate logistics systems that sustained the empire.
The therapeutic properties of the Dead Sea were also known to the Romans, with references in medical texts and historical accounts to people bathing in the sea for health benefits, to the use of Dead Sea mud in treatments, to physicians recommending Dead Sea therapy for various conditions. The Roman appreciation for bathing culture, for spas and therapeutic waters, extended to the Dead Sea, making it part of a larger geography of healing sites throughout the empire. Whether Herod's bathing in the Dead Sea seeking relief from his ailments was influenced by Roman medical ideas or represented independent tradition is unclear, but the convergence of Roman and local appreciation for the sea's therapeutic properties is notable.
The military and strategic significance of the Dead Sea region during Roman times derived partly from its resources, but also from its position. The region formed part of the frontier zone between Roman-controlled territory and the regions to the east and south, areas sometimes controlled by Rome's enemies or by independent Arab kingdoms. Controlling the Dead Sea region meant controlling routes, meant denying resources to potential enemies, meant maintaining security in a sometimes turbulent area. The fortress of Masada, built by Herod but occupied by Roman forces after his death, exemplifies this strategic thinking, a strong point controlling routes and dominating the landscape. The Roman period saw significant development around the Dead Sea: construction of roads and way stations, establishment of customs posts and military garrisons, integration of the region into imperial administrative structures. This development changed the landscape, increased human impact, intensified exploitation of resources. The pattern that would continue through later periods of stronger central control correlating with intensified resource extraction and development, began in earnest during Roman times. The Roman luxury trade based on Dead Sea products was part of a larger story about human relationships with natural resources, about how valuable materials create economic incentives for exploitation, about how distant markets can affect local environments. These patterns, visible in the Roman period, have only intensified in modern times, raising questions about sustainability, about limits, about whether resources should be managed for short-term maximum extraction or for long-term sustainability. The Romans did not face these questions in modern terms. Their understanding of environmental limits and long-term sustainability was different from ours, but their actions set precedents, established patterns of thinking about the Dead Sea as resource that continue to influence how it is treated today.
This prophecy has been interpreted in multiple ways. Traditional religious readings see it as describing conditions during the Messianic age, when creation will be restored to its original perfect state, when the curse affecting the Dead Sea region since the destruction of Sodom and Gomorrah will be lifted. Environmental activists have sometimes invoked it as inspiration for Dead Sea restoration efforts, though few literally expect miraculous transformation of the kind described. The image of the Dead Sea teeming with fish, its shores lined with productive trees, resonates as a vision of environmental recovery, of restoration of natural balance, regardless of one's interpretation of its prophetic status. Joel chapter 3 contains another reference that some interpret as relating to the Dead Sea. A fountain will flow out of the Lord's house and will water the Valley of Acacias. The Valley of Acacias, Wadi Acacias or Wadi Araba, is the region of the Jordan Rift Valley south of the Dead Sea, and the prophecy of water flowing there has been connected to visions of regional transformation, of the desert blooming, of life returning to barren places. The Qumran community, those sectarians who likely deposited the Dead Sea Scrolls, had their own eschatological visions that may have related to the Dead Sea, though their texts focus more on cosmic and spiritual transformation than on specific geographical changes. The fact that they chose to live beside the Dead Sea, in one of Earth's most inhospitable environments, may itself be significant, perhaps seeking to embody restoration, to demonstrate that life and holiness could flourish even in places of death and desolation.
Islamic traditions also contain references to the region of Sodom and Gomorrah, to the destroyed cities and the barren sea, though with less focus on future transformation than in Jewish and Christian traditions. The Quran mentions Lot and the destruction of the cities, warning against similar sins, but does not develop extensive eschatological visions specifically focused on the Dead Sea's future. Modern environmental predictions about the Dead Sea's future are based not on religious prophecy, but on scientific modeling, on projections of water balance under different scenarios of climate change and water management. These predictions are generally pessimistic if current trends continue. Continued decline in level, possible splitting into multiple smaller water bodies, increased sinkholes and environmental degradation, eventual stabilization at much lower level and with different characteristics than today's sea. More optimistic scenarios, dependent on significant interventions like the Red Dead Canal or major reallocation of water resources, project stabilization or even modest recovery, though not to historical levels. These scenarios require political will, substantial investment, regional cooperation, all uncertain but not impossible. The most optimistic realistic scenario might see the Dead Sea stabilized at a lower level but maintained as a substantial body of water, its unique characteristics preserved even if its size is diminished. The connection between ancient prophecies of transformation and modern environmental scenarios is indirect but intriguing. Both imagine the Dead Sea being different than it is now, being changed by the introduction of fresh water, being transformed from lifeless to living. The mechanisms differ. Prophetic visions invoke divine action, environmental projections invoke engineering and water management, but the core image of transformation remains similar. This convergence raises interesting questions about the relationship between religious imagination and environmental restoration, about whether spiritual visions of how things should be can motivate practical action toward making them so. Some religious environmental activists have explicitly connected biblical prophecies about the Dead Sea to contemporary restoration efforts, arguing that working to save the Dead Sea is fulfilling divine intentions for creation, is participating in the restoration that prophecies describe. This theological environmentalism sees conservation not as secular concern, but religious duty, as part of broader human responsibility for stewardship of creation. Whether this theological framing increases political will for Dead Sea conservation or merely adds another voice to ongoing debates is difficult to determine, but it represents an interesting fusion of ancient religious texts with contemporary environmental concerns. The symbolic weight of the Dead Sea in religious consciousness, its role as setting for biblical narratives and prophetic visions, affects how decisions about its future are received and understood. For many believers, the Dead Sea is not merely a body of water, but a sacred landscape, a place where divine actions occurred, where prophecies may yet be fulfilled. Decisions about its fate thus carry weight beyond environmental and economic considerations, touching on questions of religious identity, sacred history, eschatological hope. The secular predictions of environmental scientists and the sacred prophecies of religious texts operate in different registers, use different languages, make claims of different kinds, yet both address the same basic question: what will happen to the Dead Sea? Both imagine futures different from the present, both project transformations based on their respective forms of knowledge and vision. Holding these different predictive traditions together, allowing them to inform each other without conflating them, may enrich both environmental policy discussions and religious reflection on creation and stewardship. The Dead Sea's future, whether described in prophetic language or in environmental science terminology, remains uncertain, dependent on human choices still to be made, on whether the necessary cooperation and resources can be marshaled, on whether the region's people and governments choose conservation over continued exploitation. The sea waits,
patient as it has always been patient, responding to whatever forces affect it, divine or natural or human, with the slow processes of chemistry and physics that have governed it for millennia and that will continue to govern it, whatever choices humans make about its fate.
The Dead Sea persists. This simple statement carries weight when you consider how much has changed around it, how many civilizations have risen and fallen within sight of its waters, how dramatically human presence and impact have increased over centuries and millennia. The sea has witnessed the full span of human history in this region, from the earliest settlements through the biblical period, through the rise and fall of empires, through the religious transformations that have made this land sacred to billions, through the conflicts and peace agreements, through the modern development and the contemporary environmental crisis. And through all of it, the sea has remained, its essential character unchanged even as its size and condition have fluctuated. This persistence is not guaranteed to continue. The Dead Sea's future is genuinely uncertain in ways it has not been before, threatened by human actions in unprecedented ways, facing the possibility of transformation so dramatic that what remains might not be recognizable as the same sea that has existed for thousands of years. Yet the persistence we can still observe, the fact that the sea is still here, still fills its basin with dense water, still reflects the sky and the surrounding mountains, still draws visitors and researchers, still supports the minimal extremophile life that has adapted to it, still evaporates under the desert sun in the endless cycle that has defined it for so long. This persistence itself is remarkable and worthy of contemplation. The heavy waters bear weight beyond their physical density. They carry the weight of history, of all the human events that have unfolded around them, of the stories told about them, of the meanings projected onto them. They carry the weight of time, the accumulated centuries and millennia they have existed, the slow geological processes that created their basin, the patient evaporation that concentrated their salts. They carry the weight of expectations, of what we hope they will be or fear they will become, of our anxieties about environmental destruction and our aspirations for conservation and restoration. To stand at the shore of the Dead Sea is to stand at the edge of extremes, geographical and historical and environmental. You are at the lowest point accessible on Earth's land surface, standing below the distant ocean's level, descending into a place that feels somehow separate from the rest of the world. You are in a landscape that has changed little in essential character across millennia. The same harsh desert mountains, the same mineral-saturated waters, the same intense sun that drove ancient pilgrims and modern tourists to seek shade and relief. You are at a crossroads of civilizations and religions, where Judaism, Christianity, and Islam all have roots, where ancient and modern intersect, where sacred and secular exist side by side. The sensory experience of the Dead Sea is distinctive and memorable. The slick feeling of the mineral-laden water on your skin, the effortless buoyancy that keeps you afloat despite your attempts to sink, the harsh taste if you accidentally get water in your mouth, the brilliant whiteness of salt crystallizations along the shore, the heat, the intensity of sun concentrated by the low elevation and reflected by pale rocks and bright water, the sound of silence, the absence of waves, of birds calling over water, of the usual acoustic environment of lakes and seas, the light, the quality of it in this below sea level atmosphere, the way it creates colors and reflections that seem somehow more intense than in other places. These sensory experiences connect contemporary visitors to ancient ones, create a thread of continuity across time. What you feel floating in the Dead Sea is not fundamentally different from what visitors felt 1,000 or 2,000 years ago. The chemistry that creates that buoyancy is the same. The sun that beats down is the same sun.
The mountains that surround the sea are the same mountains, perhaps weathered a bit more, perhaps scarred by modern roads and development, but essentially unchanged. This continuity across time is part of what makes the Dead Sea significant, part of why its potential loss would be tragic. The Dead Sea challenges easy categorization. It is natural phenomenon and human resource. It is geological feature and religious symbol. It is ecosystem, however extreme and limited, and industrial raw material. It is tourist attraction and site of scientific research. It is heritage from the past and concern for the future. Trying to reduce it to any single category misses the complexity, the multiple dimensions of meaning and significance that have accumulated around this body of water over the long history of human engagement with it. Perhaps what the Dead Sea ultimately represents is limit, the limit of salinity that water can support, the limit of depth below sea level that land reaches, the limit of environment that life can tolerate, the limit of extraction that a resource can sustain, the limit of human impact that a natural system can absorb before transforming into something else. These limits define what the Dead Sea is and constrain what it can be. They also serve as reminders of broader limits, of the finite nature of resources, of the boundaries within which ecosystems function, of the consequences of exceeding sustainable use. The questions facing the Dead Sea are not unique to it, but represent in concentrated form questions facing many places and many resources. How do we balance economic use with environmental preservation? How do we coordinate action across political boundaries to manage shared resources? How do we make decisions that account for both immediate needs and long-term sustainability? How do we value things that cannot be easily quantified economically? Beauty, cultural heritage, scientific importance, spiritual significance. How do we live with uncertainty, with incomplete knowledge, with the possibility that our actions may have consequences we cannot fully predict? The Dead Sea does not answer these questions, but it poses them with particular clarity and urgency. The stakes are tangible. A body of water that has existed for millennia potentially disappearing or being fundamentally altered within this century. The timeline is compressed. Change is happening not over geological ages, but over decades, visible within single human lifetimes. The causes are clear: water diversion and mineral extraction, human choices that could be changed if will and resources existed to change them. The consequences are visible: the receding shoreline, the sinkholes, the degraded environment, the economic impacts on tourism and other industries.
What will happen to the Dead Sea? The honest answer is that no one knows for certain. The sea's future depends on choices not yet made, on political developments not yet unfolded, on whether regional cooperation can be achieved, on whether conservation can be prioritized, on whether the necessary resources can be mobilized. What we can say is that doing nothing means continued decline, that without intervention, the sea will continue shrinking, will potentially split into smaller water bodies, will be transformed in ways that may be irreversible. We can also say that intervention is possible, that the technology exists to stabilize or even restore the sea, that the main obstacles are political and economic rather than technical. The Dead Sea has survived many crises over its long existence: droughts and floods, invasions and wars, changes in climate and in human use. It has shown remarkable resilience, remarkable capacity to persist even as conditions changed. But resilience has limits, and the current crisis may be pushing beyond those limits, may be forcing changes too rapid and too severe for the sea to absorb and recover from. Whether the Dead Sea of the future looks anything like the Dead Sea of the past depends on decisions being made now and in coming years, on whether preservation is valued sufficiently to justify the costs and efforts it requires. The heavy waters of history continue to flow toward the future, carrying with them the accumulated weight of the past, bearing toward whatever fate awaits. The sea remains, for now, patient and present, strange and wonderful, dying perhaps, but not yet dead, still offering its lessons and its mysteries to anyone willing to descend to its shores, to float upon its dense waters, to contemplate the extremes of chemistry and geography and history that meet in this remarkable place. The end of the story has not been written. The final chapter remains open, the future uncertain. What is certain is that the Dead Sea matters, has mattered, will continue to matter, whether it persists or vanishes, whether it is saved or lost, whether we prove adequate to the challenge of preserving something ancient and irreplaceable, or whether we allow it to disappear on our watch. Another casualty of the Anthropocene, another loss to add to the growing catalog of things we have let slip away.